Good morning, everyone. On behalf of the California ISO, I'd like to welcome you to the Generation Deliverability Methodology Review Initiative stakeholder call to discuss the issue paper. My name is Caitlin McGee, representing the Stakeholder Affairs Group here at the ISO, and I'll be facilitating today's meeting. I'm also joined by Neil Miller, Vice President of Infrastructure and Operations Planning, Robert Sparks, Senior Manager of Regional Transmission South. As a reminder, the presentation and agenda for this meeting is posted to the Policy Initiatives webpage. When you're on the Cal ISO's homepage, you can find that under the Stay Informed tab. Before we get started, a few housekeeping reminders today. This call is being recorded for informational and convenience purposes only. Any related transcriptions should not be reprinted without the ISO's permission. We try to structure these meetings in a way to stimulate dialogue and engage different perspectives, but we do ask that you keep comments professional and respectful and to try to refrain from repeating what has already been said. There are a few ways to ask questions, make comments today. If you're connected through audio using your computer or using the Call Me option in WebEx, you can select the raise hand icon at the bottom right of your screen on the toolbar, or you can input your question in the chat to all panelists, and I'll read it aloud for you. And then if you're joining us today with the audio only line, you can press #2, and that'll add you to the queue. When you're making your comments or questions today, please remember to state your name and affiliation. If you do need any technical assistance today during the meeting, please send a chat to the event producer and she'll help you out. Here's today's agenda. We'll do a quick introduction and summary of our key issues, talk about the on-peak deliverability methodology review. We'll also talk about the review of the on-peak deliverability methodology, stakeholder issues and concerns, off-peak deliverability methodology, and review the key issues for next steps. And real quick, before I hand it over to Neil, we'll walk through this image, which really shows the Cal ISO's policy initiative stakeholder process. And you can see here, we're at the beginning of that process for the proposal development, talking about the issue paper today. So with that, I will hand it over to Neil.
Okay, thank you, Caitlin. Thanks for the introduction there. Hi, I'm Neil Miller, VP of Infrastructure and Operations Planning with the ISO. There are a few sections here I just wanted to clarify up front. Danielle Mills was going to be covering a few parts of today's presentation, but she's not available, having to help manage a family health issue. So I'll be covering the pieces that Danielle would have otherwise covered. Robert will be walking through the main discussion around the methodology itself and some of the technical issues people have raised with the methodology. I just wanted to mention that up front because I know there was an expectation Danielle would be participating here today. I do want to thank you all for participating in this. The resource adequacy issue is a very important one. The use of the ISO's deliverability methodology to assess that resources can be reasonably available to help meet system needs at times of stressed conditions. The purpose of the deliverability methodology itself is very important to us, especially given the number of times over the last 3 years where the system has reached those stressed conditions and been so dependent on the ability of the resource adequacy fleet to provide service. Also wanted to recap before we get into the deliverability discussion that resources have to first meet their basic interconnection requirements so that they can be reliably connected and can then choose to operate energy only without providing resource adequacy capacity or seek the higher level of service that they are deliverable, and those resources can seek to provide resource adequacy capacity. Next slide, please. So the deliverability methodology itself has been around for some time, originally developed in 2005. There was, of course, a comprehensive review conducted in 2019 and 2020 that was in response to the rapidly changing resource fleet and the peak shift that was occurring primarily due to distribution connected resources, really changing the critical times on the system and where our peak system stress is actually occurring. That did lead to the development of the high system need and secondary system need approach, and that was responding to the changing conditions. Other adjustments have been made since, including the relaxation associated with one WEC standard, as well as adjusting the dispatch levels for storage as the fleet evolved and as we were forecasting fleet evolution. So there were other requests for another review initiated through the ISO policy catalog, raising a number of new concerns that were not expressed in the original 2019-2020 review. We put out an update issue paper in December, and at the time we had indicated a target of May 31st to put an issue paper out. We did subsequently have to delay that issue paper by 2 months, largely due to bad planning on my part. That overlapped almost entirely with getting the transmission plan out the door, which was a major undertaking this year, and the technical staff needed to support both issues, couldn't be in two places at the same time. So that did result in a bit of a delay of getting this initiative going, but we are looking to have this in place in time for the next time we would be applying these methodologies. So if I could turn to the next slide. I also just wanted to spend a minute on touching on how transmission needs are actually identified and managed to help provide some context for today's methodology discussion. Of course, the transmission planning process approves the larger area deliverability upgrades for preferred zones. That is where the bulk of generation is relying on when they move through the interconnection process. And then that capacity is allocated among resources that are moving forward. The generation interconnection process itself really tends to address the smaller local deliverability upgrades that depend on which specific resources inside a zone actually move forward. It addresses the reliability requirements to allow those resources to physically connected be energized, and their interconnection requirements themselves. So this is the general context in which we'll be having the discussion. I should also mention that as we're looking at the deliverability methodology, we did see needing to align this review with the ongoing interconnection process enhancements effort, because the methodology we're applying and the needs it is meeting are definitely synchronized or geared to the interconnection process itself, the evolving resource fleet, and to some extent, the evolution of the RA program that is also responding to the changes in the resource fleet and the much more carefully orchestrated dependency on resources to work together to provide reliable service. So with that context, if I could just move to the next slide. We did include a table here of what we saw as being the 7 areas of trying to aggregate and capture the different concerns we've heard to this point and how we could see moving forward with them. I'll just touch on them briefly here, but I wanted to be clear that we wanted to capture and try to bracket and categorize these issues and look at how, where they should be addressed, perhaps provide some first thoughts on how. I thought this would provide some context then as Robert goes through the more detailed methodology discussion. And then after the detailed discussions around the methodology and some of the specific concerns stakeholders have raised, I would like to circle back. We have some slides at the end we would walk through on each of these one at a time and talk over those particular issues and how we're currently seeing moving forward with potential solutions. This is an issue paper, so we'll be looking forward for your feedback, but we thought putting this out front so that you could see, provide some context earlier would help the follow-up discussion. So we do see issues and concerns around the study of the high system need and secondary system need. Is the secondary system need actually still required? that's a good discussion to have, and it's also an important discussion at the same time that the Public Utilities Commission is actually moving to studying from a resource perspective even a broader range of scenarios, moving to a 24-hour slice of day approach. There's a lot of concern around the consideration of where N-2 contingencies on double circuit towers are addressed. This is also a concern to us about the timing of the upgrades that have been that are needed to meet those requirements in our current methodology. And we do want to explore how best to address those concerns, which we see heavily influenced by the timing of getting the upgrades in place. There's an overarching concern about transmission owner timelines being extended for deliverability upgrades, regardless of what's driving them, and the disruptive effect that's had on resource PPAs and in-service states. And that's obviously a concern to us as well, given our overriding concern that we need to get a lot of resources through our processes and connected as quickly as possible, with the very daunting challenges we have on getting new resources added to the grid over the next 10 to 20 years. The issue of Diablo Canyon and access to the additional capacity that would be available after Diablo Canyon retires has been raised, and we'll need more discussion about that. The issue about local capacity resources being a separate product, separate and distinct from also providing system capacity, that's raised some really interesting questions that we see probably needing a bigger discussion, but in the RA initiative, as it does essentially create two separate products. We'll also be exploring and wanting to keep an eye on the issues around softening the current requirements altogether. This has been a concern to us around how our methodology dovetails and what is the expectation of RA capacity to actually be there and be what we're relying on in stress system conditions. And there were also concerns around dispatch levels. So we can have a good discussion about exceedance-based output levels versus LOLE-derived qualifying capacity levels for intermittent resources. So at the end of the day, like I said, with all the different feedback we've heard on different things, this is how we've tried to categorize the 7 issues. After we go through the detailed methodology discussion, I will want to circle back and go through each of these in turn with the benefit of Robert's material having been covered. So that's the plan. And the next step would be to turn it over to Robert, but I'll stop there to see if there are any questions I can help with up front. Except I would not want to get into detailed questions about these issues, given that that is the agenda item for after the following presentations. Let me stop there, though, and see if there are any questions I can help with.
All right, and just a reminder, folks, you can use the raise hand icon at the bottom right of your screen or enter your question into the chat to all panelists, and I'll read it aloud. All right, Neil, it doesn't look like we have any questions at the time.
Okay. Well, thank you then, and I'll turn it over to Robert Sparks to walk through the deliverability methodology itself. Robert?
Thank you, Neil. So, as Neil mentioned, the following slides provide a review of the on-peak deliverability methodology, and then we'll get into some of the other issues in more detail as well. Next slide, please. So pages 10 through 13 of the issue paper describe how the deliverability study base case is prepared. A high-level description is, as shown on this slide, or as follows. Internal generation is dispatched in the base case to evenly distribute the total available generation across the system. Since all capacity is needed in these resource shortage conditions that we're studying, it is dispatched close to its maximum available capacity without consideration of cost. When you're short on resources about to shed load, you don't worry too much about economic dispatch of generation. Imports are all modeled at the maximum import capability levels, the MIC levels, and load is modeled at the summer peak level. Next slide, please. So after setting up the base case, the PowerGem Terra CAISO deliverability analysis module is used to perform the analysis on the base case. This is an automated tool that is used to identify and analyze generation groups. And generation inside the study group is increased during the study. The process is basically intended to test the ability of resources inside of the study group to be dispatched at full available output when various resources outside the study group are forced out and are unavailable. Next slide, please. Conventional generation is studied up to their NQC values. Intermittent generation dispatch values are determined based on stochastic analysis of the production during resource shortage conditions. The underlying objective is to count the equivalent value of the resources during resource shortage conditions. However, this equivalent value is based on a range of production values. The ISO deliverability methodology currently studies two different values for intermittent resources, the HSN value and the SSN value, which I'll get into in the next slide. Next slide, please. The highest system need scenario represents when a capacity shortage is most likely to occur. It represents the wind and solar resources at their 20% exceedance value for hours 19 through 22, and for hours when there's actually a resource shortage condition in this stochastic analysis. And you know, as a result of going through that analysis, it ends up representing a very low solar output level. The secondary system need scenario represents hours when solar is dropping off, the sun's, you know, setting down on the horizon sort of thing, and dispatchable resources are ramping up to continue to serve the load with that solar dropping off. And during that, we've seen that a capacity shortage could still occur. The intermittent generation is in the SSN study is represented by its 50% exceedance value, and during the SSN period, which is hours 15 through 18, again, during resource shortage conditions within the stochastic simulation. And again, and going through this, even the SSN actually represents a fairly higher than the HSN, but still a fairly low solar output. Next slide, please. So as shown in this graphic, the HSN solar study amount is very low and occurs when the risk of unloaded capacity margins is the highest. The blue bars shown in this diagram, most of you have probably seen this diagram, but the blue bars represent the risk of low unloaded capacity margin. So the tallest blue bar there means you've got a fairly high risk of a low unloaded capacity margins. It also shows the SSN solar output, which is still fairly low compared to the maximum solar capability. And you can also see the blue bars, there's still a reasonable risk of low unloaded capacity margins or resource shortage conditions during the SSN time window. Next slide, please. So the current HSN and the SSN study values are shown in this table. Just as, you know, an example of how to read the table, in the HSN study, a 100 megawatt solar resource in the SCE area would be studied at a value of 10.6 megawatts or less. And then in setting up the base case, that 100 megawatt resource would be modeled at actually 80% of that 10.6 megawatts or 8.48 megawatts in that starting base case. And then when we go through and use the automated tool, it may turn up that resource up to a maximum of 10.6 megawatts in the HSN study. So I can stop here and see if there are any questions on what's been covered so far, or we can move on if there aren't any questions.
We do have a question from Susan Schneider with Phoenix Consulting. Go ahead.
Hear me?
Yes.
Yeah.
Okay. Anyway, just I'm just curious. The offshore wind numbers in the secondary system need scenario. How I know the solar and wind were based on, I thought, recorded actual data, but I'm wondering how it is you got the offshore wind numbers, the 3 that you have there.
So I'll get to the offshore, but just to sort of clarify, so the solar and wind, again, are based on a stochastic analysis. So we put in actual solar and wind profiles into the stochastic, into the model, the Plexos model, and it was based on historical data, but it's a simulation of, I don't know, I forget how many, 5,000 or 500 different possible scenarios. So it's not actually historical data, if you will. These are all just probabilistic type analyses. So for the offshore wind, there is, wind measurement towers, MET towers, I think they call them, but basically weather towers or buoys or something out in the ocean, and they can measure the wind. NREL has the data. Probably many entities have the data. And using that data, we arrived at these values. Now, we are taking a closer look. We're trying to get updated data and taking another look at the offshore wind. But anyway, hopefully that answers your question.
It does. And just to clarify on the storage for the secondary system need, for projects coming online in 2024 and 2025, we are still using the 80% number for the secondary system need and not 50. Is that right?
Yeah, as the deliverability methodology document posted on the ISO website and referenced by the ISO tariff, as it's stated in that document, basically for the 2024 NQC study, which we're actually working on right now, we will use the 80% storage dispatch for that study. All the other studies we're using the 50%.
Okay, I thought it was 2024 and 2025. It's only 2024, and then 2025 we go down to the 50%.
I'd have to go check the document. I forget.
Okay, and it's slightly off topic, but if you're looking at deliverability transfers from storage to or from storage on for the secondary system need number, are you using, if the transfer will happen in 2024 or potentially 2025, depending on your check there, would you use the 80% number or the 50% number?
So it depends on, I think, when the resources are expected to be in service.
Okay, so it's the in-service date that really matters for that purpose?
Yes.
Okay. Okay, great. Thank you. Those are all the questions I had. Thanks, Robert.
All right, we have Pushkar Wagle with Flynn Resource Consultants.
This is Pushkar Wagle from Flynn Resource Consultants. Can you hear me okay?
Yes.
Morning, Robert. Yeah, first of all, I just want to start off by saying that we really appreciate your openness and sincerity in conducting this initiative, and clearly highly appreciate the 7 considerations that Neil just laid out on page 9. I just had a quick clarifying question. I was wondering whether you could elaborate a little bit more on the MIC value the maximum, let's say, summer peak simultaneous? I guess it's based on the historical net imports by branch group. Is there any distinction that you make for HSN versus SSN for how you determine the maximum import capabilities that can be allocated for RA purposes, for instance?
Yes, yeah, thanks for that's a good clarifying question. So for the HSN we use the MIC. For the SSN, which is earlier in the day, more solar production, we try to work. We try to review the same days that the MIC is based on and try and adjust it. So I think the solar the import is a little bit lower in the SSN study, but again, still based on the same historical data. So there is a slight adjustment. Yeah. I think it's mentioned in the deliverability methodology document.
Gotcha. Great. Thank you so much. That's all I had.
All right. Up next, we have Kanya Dorlan with the Public Advocate's Office.
You hear me?
Yes.
Yes.
Yes. Okay, so I just wanted to clarify my understanding on slide 13. You say generation capacity, steady assumptions, intermittent generation dispatch values are determined by stochastic analysis of their production during resource shortage conditions. And then you have the table on page, I guess it's slide 16. And so these are the random values for the intermittent resources during shortage conditions. Is that?
These are the resulting values that were arrived at after going through that analysis of the, so essentially the stochastic analysis is done by both the ISO. We look at various sources, but we try and use both short-term and long-term simulations. We actually received some from the CPUC as well. But then going through the post-processing that was described in the slide slightly, and in the methodology document, these are the values that were arrived at. I think you used the word random, or maybe I misheard, but
yeah, I was maybe being reductive, but my understanding of stochastic is kind of like it's, kind of like a sorting, random sorting, but it does make sense that solar is not always available, wind is not always available, so it wouldn't be 100%. So it does make sense that it wouldn't be 100%. I'm just making the connection is all. So that's all I wanted to ask. Thank you.
Yeah, just to, as a reminder, these values do not determine the qualifying capacity of the generators. These are simply just what we study in the deliverability study. Okay. I know when we changed the storage to 50%, it seems like there was some storage developers who were concerned that we're only going to count the storage for 50%. That is not the case. We study them at 50%. They count whatever the QC methodology says they count for, and that's not something the ISO does. We just test their deliverability, and then if they're not deliverable, we have to adjust the QC down to arrive at the NQC. Anyway, is that all the questions?
Yeah, thank you. I just wanted to make sure I'm following. Thank you.
And then we do have two more hands raised. The next one being Doug Karpa with Peninsula Clean Energy.
For walking us through this is really appreciated. Couple of, or maybe one big compound question. My understanding was that you're basically modeling the system as it is, which makes me wonder, like, why is offshore wind in this study if it doesn't exist yet? And I guess that's for later years, you're assuming that it will be in existence. maybe start with that.
Well, really the first time a generator gets studied in the deliverability study is in the generation interconnection process. So a generator coming through the interconnection process, practically none of them exist. In fact, most of them will never exist, but with our current queue. But anyway, so we are looking into the future of like 5 years in the interconnection studies, and even the NQC study, which is for the next year. Right now, we're working on the 2024 NQC study. Even that's in the future. So none of these are none of these are real-time studies. These are planning studies.
Cool. Yeah, that's super helpful. And then I was curious, both like what is the rationale for, like, if I understand it right, you're modeling energy storage as basically only being capable of discharging at 50%. Like, we're assuming that just the batteries aren't full yet at that time. And a sort of follow-on question of, like, if I'm understanding this right, that actually may make things more deliverable because there's less dispatch on the system, so there's more, like, there's less congestion. And if you were to say put that at 100%, it might actually have the impact of making things less deliverable because there's more being discharged onto the system in the SSN test. Is that approximately right, or am I like way out in left field?
No, that sounds about right. I pretty much agree with your characterization. Yes.
Cool. And so the 50% is just like, that's what we typically see happening, storage in those hours.
Yes. Well, last year we talked about that exact question. In fact, that's when we made the adjustment from 100% in the SSN to 50% for storage. So we had basically a whole stakeholder meeting just about that one question. But yeah, that's what we were seeing in the most recent resource shortage days, which unfortunately we've had a few of those lately, and even in future simulations, that's what we were seeing.
Awesome.
For the
Thanks
storage during that SSN time window.
Cool. Thanks.
And then we have one more question from Dariush Shaharmahadi. Go ahead.
Hi. Hello, Robert. You can hear me, right?
Yes, hi, Dariush.
So my question is related to offshore wind during HSN. You noted that the data, you described how you get the data of offshore wind data, predicted output, point well taken. You also described that you use an exceedance method, I think 20% exceedance method for HSN condition. Is that correct?
Yes.
And
yeah, under especially for wind, we look at the 20% exceedance when we see a shortage of resources, essentially through the stochastic analysis, or like for the offshore wind, we may not be able to run a stochastic analysis, but we'll look at the load. We'll try and look at when the load's really high, and look at the 20% exceedance during that sampling of hours.
So thank you. So you basically, your assessment, whatever it has been for offshore wind during HSN, whatever your assessment has been, you notice that offshore wind for HSN should be represented at 100% capacity. In other words, if it's 20% exceedance based on your assessment of, looking at this data from NREL or met stations that are out there in the sea, you discovered that these resources are available 100% of the time during HSN, at least for the purpose of these studies, because they 20% of the time or more, or whatever other measure you have, that they are available 100% of the time. And at 100% capacity for that duration.
Well, again, we're looking at the 20% exceeds. What we're saying is that when we're in a resource shortage condition, we would like the resources to be deliverable 80% of the time. So we're willing to live with 20% of the time those resources will actually not be deliverable, fully deliverable.
Okay, and you found out that
the general concept.
Yeah, and you found out that 100% capacity is the right number based on that kind of thinking, correct?
That, well, like I said, we're taking a look at it. Yeah, definitely the 100% raises eyebrows a bit, and so we're taking a look at that. But that's what we have right now. Yes, you know, it's almost like a preliminary value, but that is what
we have noticed you using it at 100%. Yes. So the second question I have is, in your deliverability assessment, you figure out how much so-called TPD capacity is available for a resource, and that capacity is effectively allocated to that resource so that when for its use, and then the next cycle you find out whether there's enough TPD capacity left using this Tara tool, that's a DC power flow tool, to find out how much TPD capacity left to be given to next set of resources, and if there's enough left, they can get deliverability or not. Now, in this assessment that you do to determine how much TPD capacity you can allocate to a resource, if an offshore wind that based on a QC application maybe seems to have a qualifying capacity of about 50% of its nameplate, not 100%. If the idea is to make sure whether that 50% can be delivered to the grid, given all the other resources you have available, that grid has available, if PUC set is wondering whether I'm only counting on offshore wind for 50% of its nameplate, even if it's 100% there and so on, I'm only counting on the offshore wind for 50% of its capacity. I don't know exact number, but I think it's about 50%. Why do you try to find out if that offshore wind, even if it had output, additional output, it would not count for RA capacity. It doesn't help with peak demand plus 15 to 20% extra. It doesn't count. Why do you try to give it TPD capacity for 100% of its capacity, as opposed to 50% that the grid counts? I mean, the RA capacity count on it. Why are you giving this additional TPD capacity, or setting it aside? Nobody sees the TPD capacity. Everything is in your accounting system. Why are you setting aside 100% TPD capacity of 100% of its output, while the grid only relies, while the RA counting only relies on 50% of its capacity? Is this a matter of you trying to solve a curtailment issue, as opposed to finding out what resources can get the qualifying capacity to the load, or are you trying to solve a curtailment issue in terms of that resource not getting curtailed too much or something?
Yeah, that was a long question. I couldn't help but remember.
Maybe this is one of those questions that
keep the question short.
That Neil mentioned we should discuss.
One thing that I also got distracted at the beginning was actually the Terra tool starts with a DC analysis, and then it actually finishes with an AC analysis. So it is a full AC analysis. But I think that the gist of the question is, you know, why are we studying these generators at a level that's higher than their NQC or their QC? I think that's just basically your question, and that is addressed actually later in the presentation, because that was clearly a question, an issue raised in response to the December 2022 paper. But but I'll provide the answer now, and you know, unfortunately, there'll be a little rerun when we get to that slide. So we're talking about wind generation, and everyone, you know, we all go outside, and sometimes the wind's blowing like crazy, and sometimes it's not blowing at all. And for power production, well, actually, you don't want it to blow too hard, but when it's blowing at a nice level, it produces power. But when it's not blowing at all, you get nothing. And so that 50% QC value is essentially, it's like an average value. Like I said, sometimes it's not blowing at all, and sometimes it's blowing more than 50%. And so if only 50% was deliverable, when it's blowing more than 50%, and that's not, that means you have to curtail anything more than, you know, again, in my little example I have here, a 100 megawatt wind generator, 50%, let's just say its QC is 50%, you know, 50 megawatts. And we studied it only at its QC, and we used up all the transmission, so only 50 megawatts is deliverable. When the wind's blowing 75 megawatts, that's great, except we're going to have to curtail 25 megawatts, and you only get 50 megawatts. And then when it's blowing 0, you still get 0. And so in effect, it's really not good for 50 megawatts anymore, because really that 50 megawatts is the aggregate, the average of that 75 and that 0. And the example I'll talk about later is, you know, we rely on the diversity, you know, the geographic diversity of the wind. So sometimes some areas it's blowing nicely, and some areas it's calm and there's no production at all. And those QC values are sort of taking advantage of that geographic diversity, is my understanding. And so we have to study it at the 75 megawatts to make sure that we're getting that geographic diversity.
Robert, it's still here. I probably would also like to chime in on that, because this, I think, is a pretty important issue for us, especially as we're looking at the evolution of the resource adequacy program and interconnection process as well. So I don't want to get in the way of your stream of thought, but when you're finished, I think there's another issue I'd wanted to raise about that same topic as well.
Yeah, no, I think well, that was my best attempt to answer Darius's question. So sure. Yeah, please chime in.
Okay,
I agree. It is a significant question.
Yeah. So yeah, this is a very important issue to us. So just to tag on to Robert was saying, I totally agree with what he was saying there. I just suggest another way of looking at this as well too, is that for some of these resources, the qualifying capacity levels through the current counting methodologies are based on a probabilistic approach of an assessment of the contribution of that resource over a period of time, and not necessarily the contribution that resource can actually make at the time of system peak or the critical stress hours, as Robert was saying, and which is even more complex than just I'll say, a simple average. But so we have this qualifying capacity value that a resource could be attracting a value for that is based on its contribution outside of the stress conditions, but over the remaining 8,759 hours of the year. But in order to provide some of that benefit, its output level at the time of stress needs to be considered. So, and you know, this is something that we see the RA program at the CPUC grappling with consideration of what an acceptable planning reserve margin is that gets applied to peak loads, but also recognizing that some resources are attracting a qualifying capacity value that aren't necessarily available at those critical hours. So there's also this effective PRM discussion about additional capacity that is available. So that whole issue of how a single number gets used to attribute the benefit it provides over an entire year, how that would relate to us needing to test a reasonable expectation of that resource contributing at the time of stress system conditions which is the purpose of the different methodology, really shows that there's a bit of a gap between what the qualifying capacity methodology is trying to achieve and what our test here is trying to achieve. Can we reasonably count on those resources at times of system stress, and what's an appropriate level to dispatch them at? And that's why the acceptance methodology seems to provide a reasonable indication of what are we expecting or counting on that resource to do at that stress system condition, not and what kind of counting methodology might it be used for bookkeeping around your overall resource fleet for the whole year isn't really a directly applicable number to what are we going to turn on at 7 p.m. on a bad day in September. So Robert also, as he mentioned, has a slide on page 30, and then this is another issue I wanted to follow up on near the end as well. But you know, we do see that there's a different purpose behind the calculations, and that we can't just pick one number over another because we think it's a more attractive number. That we are looking at what is the purpose of the study and what's the appropriate number to use for that purpose. So anyway, I'll back out now, but I think we might want to pursue it again later in the day as well as Robert. I don't know if you're going to revisit it on page 30 in the deck. But thank you.
Yeah, no, it's
Thank you very much.
we've got our report. Let's kind of go over it one more time. So, are there any more questions?
I did have a question in the chat. Maybe I'll read it aloud. It's a pretty big one. Maybe we can get to it briefly. It might be better for written comments. But David McMillan from Megawatt Storage Farms, first question was, weather affects loads, solar and wind output, so there are statistical correlations between these. Do your stochastic analysis model these cross correlations, and if so, where is that documented?
Yeah, so the stochastic analysis is not work that I do, so it's not documented in this presentation. We were a beneficiary of that work. So yeah, I guess we don't cite it here, but essentially we've used some of the summer assessment analysis, which is documented, the ISO's annual summer assessment analysis. We've also used the ISO's long-term stochastic analysis, looking at the future resource portfolios. That I believe is in filed testimony at the CPUC, and I believe the models are filed with the CPUC, if I'm not mistaken. And we actually, when we first created some of these numbers, we also looked at CPUC numbers themselves, the staff numbers, and I'm assuming all that's all publicly available. But to answer your question, my understanding at least is that, those stochastic models include wind and solar production values and profiles that are based on historical data and the load data that correlates to the same hours. The weather pretty much shows up in the load data, and it affects the solar production and the wind production, and all of that is synchronized, is my understanding. So it is taken into account.
All right, and then a second question from David. The 24-hour slice of day method looking at just one day may not properly model the situation where you have a long-term weather event that causes reduced renewable output, high load, and inability to fully restore state of charge at the end of every day. So over a week or more, the failure to fully restore state of charge effectively reduces storage availability. That ultimately causes lack of resources to meet load. What KISO simulations, if any, would capture these types of loss of load scenarios?
Robert, I think that I can jump in to help on that one, if you wish.
Yeah, please.
Okay, great. Yeah, no, thanks for the question. So the reason I was jumping in was that this is a really important issue to us. It doesn't directly relate to the deliverability methodology, but this is a really key issue. And in fact, we have recently hired a new director of resource assessment and analysis to help specifically with pulling the teams together to get more engaged on a lot of these broader resource planning concerns. And actually, I would steer you right now. The best document I think that's the most up to date on our view of some of these concerns is actually included in the summer assessment that we posted not that long ago, because it also includes our resource assessment going out each year for the next 5 years and touches on the 10-year projection as well. And we really see there's two different kinds of issues that we're dealing with when we're looking at the resource planning that then factors into what does your transmission system need to be capable of to deliver those resources to load. And we've been seeing that the best way to try to think about and analyze and articulate these issues is kind of by bracketing two different groups of issues. One is, I'll say, the conventional resource planning, where we're doing probabilistic analysis, factoring into the usual distribution of load profiles, weather events, across a statistically significant period of time, taking into account characteristics of resource types, and doing the more traditional loss of load expectation analysis to say, is the fleet that's being planned actually going to meet reasonable planning targets, which are usually around that 1 in 10 condition. But then beyond that, and as Robert mentioned, we have been getting hammered as a state with extreme weather events that go beyond conventional planning practices. There's a question of what else do you need to do to prepare for events that might be statistically improbable, but you're still not willing to live with the consequences when they occur. And that those more extreme events that unfortunately, like I said, the climate change impacts being felt particularly harshly here in California have that additional attention. And that's where especially strategic reserves being developed through the state programs and other measures are looking at providing that additional type of backstop insurance to mitigate those more extreme events. Now, a period of uncooperative weather, of perhaps reduced solar output, some of those events kind of transcend between the two buckets. But this is a really important issue that we're looking at from a resource planning perspective. And like I said, our current approach is to try to bracket normal course of event analysis that goes into your loss of load expectation, and then what else do you need to prepare for that goes beyond that, where you're being hit with some very extreme event that goes beyond what would be normally baked into the history that you've built up over the last 25 or 30 years. So I know that's a long answer, but I would also, like I said, this is a critical issue for us, especially as the resource planning feeds directly into the transmission planning. And I would encourage you to take a look at the summer assessment, because we did use that as a venue to touch on our current view, looking out not just for this summer, but what the longer term projection based on the current CPUC preferred system plan, what that would look like, as well as touching on this extreme event discussion. Okay.
Thanks, Neil. And then we did have a third question from David. I see exceedance percentage, like the 50% on page 14 in various analysis. Is there any detailed statistical analysis on how this percentage is chosen? So far in the CEC and CPUC materials, I haven't seen mathematical derivation of this. It seems it should be in part on their statistical thresholds used.
Yeah, so I think the question has to do with how did we choose the 20% exceedance and the 50% exceedance for the SSN, the 20% for the HSN. So again, as I mentioned earlier, it's sort of a design objective, if you will, that for the HSN in particular, that that's the most critical one. We wanted the resources to be deliverable 80% of the time. We didn't want to have to curtail them 80% of the time. But if they're producing, more than that, then 20% of the time we may need to curtail some of the generation. So it was more just of a design objective in my mind for the HSM, and then for the SSN, because that one was a little less critical. We thought more of a 50% of the time should at least filter out any egregious deliverability problems during that condition.
Thanks. And then I think we have our last question here, Nancy Rader with California Wind Energy Association.
Hi there, yeah, Nancy Rader with California Wind Energy Association. I guess I'm just scratching my head because, if we're concerned about extreme events, the concern with wind is that it's not going to be there. And yet you're assuming 55%, for Edison, that assumes more than what we're counting on is going to be there. That's not our concern. Our concern is that it's not going to be there. And by using that high level, you essentially eat up a bunch of TPD capacity. So I just don't get it.
Yeah, well, in my response to Darius's question, the angle that I'm coming from, and you'll probably want to chime in as well, or I think we both kind of addressed it, but again, that QC value is based on the stochastic analysis of many different possible scenarios of resource shortage conditions. And some of those scenarios, the wind was actually producing more. And mostly referring to the the equivalent load carrying capacity simulations, which I guess that's going to be phased out. So we'll have to see what the slice of day. I guess that'll be a 70% exceedance or something. But again, they're looking at the wind fleet and looking at what is the value of that wind fleet, and that includes this geographic diversity. And so in some areas you're getting more than the QC, some areas you may be getting zero, and or as Neil mentioned, certain times of the year you may be getting zero, certain times you may be getting more, and so that doesn't just represent one number, and they are counting on that QC. So we may worry about having less than the QC, but the analysis is counting on that QC, and that QC represents a range of production values. And we want to make sure that that range of production values that are used to produce that QC value are not constrained by the transmission system, or else it's not a valid qualified capacity value.
Well, I don't want to argue, but the fact that you're assuming way more than we are counting on doesn't make sense to us.
Yeah, in the SSN, it's I certainly wouldn't characterize that as way more. In some cases, it's actually less. The HSN wind. Oh no, I'm going to have it backwards. So in the SSN, actually, the wind values are when it's earlier in the day. That is, some of those are lower than the QC value in the SSN. In the HSN, yes, they are higher than the QC, but they're only depending on the area, 30 in the PG&E is a little higher, 60%. But that's what we saw in the analysis during that. When the sun's setting, the wind tends to pick up more. So that's a good thing. Again, the QC is more across the entire spectrum of when you have resource shortage, but during that little window, at least according to the data we looked at, the wind actually did produce, so that's that's what the analysis that's what we found. Anyway, any other questions?
We do have two more questions. Doug Karfeld with Peninsula Clean Energy, go ahead.
Yeah, thanks. I hope you weren't planning to get off this slide anytime today. Apologies for the question, but I just wanted to follow up on Nancy's question. Again, I'm very new to all this, so I'm like trying to wrap my head around how all this works. So if I understand this right, the rationale for modeling high wind production really is that you can have the wind fleet cranking and still have very stressed conditions. Like historically, we've seen that happen. And that's like, and so what we're trying to model there is those sets of conditions which there's stress in the system, loads are high, something else isn't maybe showing up, but the wind fleet's doing great, but you're still having to worry about things being congested off, essentially, at that standpoint. And I guess sort of the also looping in the statistical question, and I think the thing that comes through, theme that winds through all of this is really like, what is that really that common an occurrence, or is that just sort of some weird little corner case that happens in like 0.05% of the time? Because it guys intuitively were like where Nancy felt like she was going was like, well, if the wind fleet's really generating a lot, doesn't that mean that we're like in good shape and don't really have any, like our reserves are met and we're in fine shape? And I'm gathering from your answer that's not really correct, that we're in fine shape, even if
Yeah,
like
yeah.
the
So
wind
again,
fleet cranking doesn't tell us we're in good shape necessarily. Yeah, sorry.
Yeah, I think the one question that I heard in there was how likely is it for these
Yes.
values to basically be there? And again, we're looking at the 20% exceedance. So the answer to that is we expect to have that value 20% of the time, or higher actually than that value, but we looked at the 20% exceedance value. Again, during these, when we were shedding load, or actually when the unloaded capacity margin was less than 6%.
Right, and that's when we're looking at exceedance values, the data set that you're using is that subset of hours where we're at 6% or lower, basically.
I'm sorry, can you say that again?
When we're looking at exceedance values, the data set, when you say it's like 20% of the time, or 80% of the time, I guess it's lower than that value, it's 80% of the high stress conditions. So like if the days where like load is low and we're like just swimming in capacity, that's not even in the data set. We're not including that when you talk about the 80%. Right. Okay, excellent. Thank you.
I think this is our last question from Ed Smeloff with CERT. When will the deliverability assessment methodology be revised in anticipation of the slice of day approach using exceedance values for solar and wind?
It looks like Neil will probably have a better response than me, so go ahead, Neil.
Actually, it's Neil. I'm afraid I wasn't quite understanding part of the question. Is we're tracking what's happening with the implementation of the slice of day approach, and looking at whether or not the changes there, what additional concerns, and I shouldn't say it's a concern with the slice of day approach. It's the slice of day approach is a shift recognizing the complexity of the resource fleet that really emphasizes the changing nature of our system to provide reliability, where as opposed to having a fleet of purely dispatchable resources and managing them based on cost, we're now dependent on a very careful orchestration of different types of resources making different types of contributions to providing an overall reliable system. Batteries have been wonderfully effective at the actual peak stress condition periods, but they have to be charged. So where's that charging energy coming from? And so we're counting on resources now just not only to meet the peak load itself, but also having to count on other resources for preparedness to have those other resources available. So that's raising additional questions about what do we need to do to make sure the grid can not only be there to provide the reliability at the peak stress to let the resources that are being counted on at 8 p.m. But what to what extent do we need to do additional analysis to make sure the grid can manage the preparatory events to be ready for that window? So we're going to be watching the slice of day approach, and this is something that we're actually raising here is we have stakeholders concerned about the fact that we have a secondary system need test, which I think is actually rarely binding right now. But as the fleet continues to evolve, do we need to be looking at other times? You know, when the slice of day approach was initially proposed, we had people asking if the ISO was going to be moving from a high-end secondary system need to studying every 24-hour slice as well. And that's obviously not our plan. So we're going to be having to monitor this, work through what it means. And I do think part of this initiative that is not a quick overnight answer is that we do want to explore how should we be thinking about additional evolution of the RA program driven by that fleet complexity. And does that mean we need to expand to, is the secondary system need we're currently studying the right secondary system need? Or are there other scenarios that need to be included? We're looking ahead a few years and seeing that the summer peak situation, I mean, the morning peak could become a critical factor going forward. How prepared are we for that in terms of the expectations that are being placed on the emerging fleet to address this evolving load characteristic? So this is something we do want to dig into in this effort, and we're going to be looking for people's input on that. And I'm kind of jumping ahead now to one of my later slides, but just to tee that up.
Ed
So I
might
think we
have
probably
a clarification. Oh, go ahead.
Sorry? No.
Ed, did you want to unmute yourself and just clarify your question real quick? I see your hand raised.
Can you hear me?
Go ahead, your line. Yes.
Yes. So thank you for that answer. That was very helpful. And the only clarification that I wanted to make is, as we move to slice of day, we're going to move away from using ELCC values for determining what the the NQC is for specific resources, and we're going to be looking at using an exceedance profile for the worst day or specific days of each month and over multiple hours, including probably the SSN hours. So it is an important evolution. It will, I think, change the values that are assigned to these resources during those critical hours that are probably bracketed by the HSN and SSN hours. So I just wanted to make that comment. I appreciated the answer, and that obviously people were thinking hard about this issue.
Thank you, Ed. We really appreciate that comment. Yeah.
All right, so I think we'll move on. That's it for questions at this time.
Okay, thank you, Caitlin. So as Neil mentioned, the ISO issued a paper on December 12th, 2022, called it the update paper for deliverability issues. And we got many stakeholder comments. Thank you for the comments. And so the following slides will summarize at least the comments that were most relevant to the technical deliverability analysis, and I'll try to provide some responses. Next slide, please. So a few stakeholders raised the concern that the CAISO's practices are more conservative than other entities such as PJM and MISO. And as if you saw in the paper, the ISO researched these claims and summarized their deliverability methodologies in Table 2 as well as the ISO deliverability methodology. And I showed some of that table in the following slide. The full table's in the issue paper. But in going through that analysis, I'll just start by saying the ISO has concluded that MISOs and PJM practices are reasonably comparable to the CAISOs. But I'll get into a little more detail. Next slide, please. So the first thing, and Neil touched on this a bit, is the reliability impacts of generation projects seeking to interconnect must be assessed in addition to a deliverability assessment. And transmission upgrades are identified through that reliability study. They're identified as needed. And so the generator can't interconnect until those upgrades, those reliability-driven network upgrades are put into service. And so obviously if a generator is not in service, it can't get deliverability. So essentially, in order to get deliverability, you need to address both the reliability issues and the deliverability issues before it can be interconnected and counted for resource adequacy. So therefore, the study parameters of both the reliability assessment and the deliverability assessment must be compared in order to attain a complete comparison of, one deliverability methodology and interconnection process to another, and what a generator is going to sort of see as it goes through either process. So in looking at the table, as you can see, that MISO studies, and N-2 is obviously a big topic. There are several other parameters that we'll look at, but I'll talk a lot about the N-2 here. So as you'll see in MISO studies, N-2 contingencies are studied in their generation interconnection reliability assessment. And unlike the California ISO, where we've been using congestion management, at least assuming congestion management can be used to address any N-2 issues, or at least we'll assume they're either addressed in the deliverability study or congestion management. MISO does not allow congestion management to address any of the N-2 issues they see in the reliability study, and they basically require transmission upgrades as mitigation for those N-2 overloads that they see, N-2 contingency overloads. In addition, PJM has what they call a common mode analysis. And if you look at their manual 14B, which is on their website, you'll see that in the section, which is their deliverability section of their manual describing how they do deliverability studies, part of that section is this common mode analysis. It's actually an addendum, meaning it's part of the deliverability analysis. And they look at N-2 contingencies in their deliverability analysis. That's basically what they state in their manual, that N-2 contingencies are part of their deliverability study. And they talk about some of the details. There's some of the parameters are a little different. They may allow fewer generators to come online or to be fully stressed than for N-1s. But essentially, they still turn on a large number of generators at full output and run N-2 contingencies and require them to pass that test before they're deliverable. So basically, in short, both PJM and ISO require that N-2 contingencies be studied and mitigated by required transmission upgrades before a generator can be deliverable. And then, just quick, if you look at the defects criteria, the 5% defects criteria, that's similar. MISO and PJM all use pretty much, and the CAISO all use this 5% number, which is not a coincidence because we looked at PJM's, we studied theirs very carefully when we created ours many years ago. The number of generators that are maximized in the generation pocket is, again, very similar to the CAISO methodology between PJM, MISO, and CAISO. So again, based on all that, we found they're all fairly similar. Next slide, please. And I'll cover a couple slides here and then go to questions. So a little more on the N-2, there's been a lot of focus on that. The next two slides focus on the N-2 contingencies. The NERC reliability standard FAC2 basically is the standard that is for doing interconnections to the grid, generation interconnection, load interconnection, transmission interconnections. But just focusing on the generation interconnection part, it requires generation interconnection studies to evaluate system performance in accordance with another NERC standard, reliability standard TPL1. And so essentially you have to follow TPL1 studies in your interconnection studies. And TPL1 requires the analysis of common mode N-2 contingencies. Next slide, please. So in the comments that were submitted in December, CalWIA suggested that MISO and PJM do not consider N-2 contingencies in their analysis as part of the requirement for obtaining deliverability. And as I just went through, this is simply not the case. Both MISO and PJM do require generation interconnections to be responsible for transmission upgrade mitigation for N-2 contingencies in their generation interconnection studies and in order to get deliverability effectively, as I described. AES Clean Energy believes that the deliverability methodology should only consider N-2 contingencies the way they are considered in real-time operations. However, if we basically we do not mitigate N-2 contingencies in the planning horizon, then they'll become unmanageable. And you see the hundreds of gigawatts, interconnecting to the grid. It would become unmanageable if we don't mitigate the N-2 contingencies in the operating horizon. It would just be much less severe than the system we operate today. Next slide, please. However, the ISO does see some possible mitigation options to the N-2 concern. Earlier this year, we went through some RAS guideline updates, and we were aware of the concern of the N-2. So we did include in there a provision that the RAS guidelines can be relaxed while waiting for an upgrade to be constructed. So that's certainly one option. Or if a transmission project is delayed, through permitting, construction, supply chain, whatever issues, then the N-2 requirement, could also be relaxed. Again, it's not going to be forever, and it won't, shouldn't be a huge accumulation of overstressed grid. During the operational horizon, we could relax that N-2 requirement effectively, provided that that reliability can be maintained. Or another option is interim deliverability status. Actually, all this would be interim deliverability status, but could be provided as long as the planned mitigation is at least under development. Again, as long as the operational concerns are addressed. However, proactively addressing these N-2 operational reliability concerns would likely require some enhancements to the reliability studies that are performed in GitApp. And so that it's a whole package of analyses that goes together. We would have to kind of look at the whole package and see what sort of what would need to be done, so there's no unintended consequences. So with that, we might have some questions, or we can move on.
Do have some questions. Let's see. Let's start here with Pushkar Wagle. Go ahead.
Robert, this is Pushkar Wagle from Clean Resource Consultants. Can you hear me?
Yes.
Yeah, I think this MISO and PJM comparison, I think it may warrant more discussion than we could have in this call. But you're right, MISO clearly states in the generation interconnection BPM that the contingency files for deliverability studies should only contain P1 and P0 contingency. And I think you're correct that the P7, which is the sort of common mode structure, is simulated as part of their ERIS, or energy resource interconnection service, which is essentially the reliability study that we do. But then you're not doing this 5% defects business is not used for the N-1 or N-2 in those reliability studies, the way CAISO studies that as part of deliverability. So it's intrinsically different to study it as part of the reliability assessment versus what we do here. And then the deliverability study, or this network resource interconnection service, or NRIS, in MISO, that's clearly studying, as I said earlier, in terms of P1, which is the single element out contingency with the 5% defects. And I'm no expert on MISO, but I understand from some of those experts, and if they're on the call, they may want to chime in. But in terms of the 5% defects, also there is sort of distinction between, there are nuances in terms of for contingencies that are, I guess, less than 345 kV, they use 10%. If it's greater than 345, it's 20% defect. So clearly it's a a little bit different way it's been approached at MISO. So it's not always 5% defects. And if you just read the PJM's manual 14B on the deliverability of generation, section C.3, you're absolutely right that when I read it, I also had the impression that they do N-2 for the generator deliverability test. But by talking to some of the PJM experts, I sort of, it's a little bit still more nuanced in terms of, it does appear that they test the N-2 compliance for reliability studies using some reasonable assumptions on the energy dispatch expected during those peak conditions. And then having completed those studies, it tests the deliverability of, again, generation capacity only under N-1 contingency. So if you look at the manual 14B and read it, as it clearly sounds like they're doing exactly the same as what we are doing here. But there might be something, all I'm saying here is that we need to have a little bit of better understanding of how things are done in PJM and MISO in terms of the deliverability assessment.
Yeah, so there's a lot of, I'm not sure there was any question, but just sort of a response on that, if you look at MISO's BPM, they do talk about using the MUST program in their reliability analysis. So they are looking at, using basically a linear optimization program to look at stress system conditions. It's not just like building one base case that, it's historical data, let's run a couple N-2. They are using similar tools, even in their reliability analysis, it looks like to me. But anyway, I don't think California is obviously different than the Midwest and different than the East Coast. The systems are different. The use of RAS is wildly different. We use a lot more RAS than any of them. There's so many differences, it would just probably not be fruitful to try and dial in exactly every little detail. And I think we need to do what works for California. And we've done a fairly exhaustive analysis already, and like I said, they're reasonably similar. But anyway.
Anyway, what I wanted to say, that it appears that they're quite different, and maybe the MISO's approach of studying these things mostly in reliability assessment, and then looking at more reasonable contingencies like N-1, P0 and P1 kind of contingency in the deliverability situation, when there are some more stringent assumptions made, in our opinion, might be a way to go. But we could have a follow-up discussion, and we'll file some written comments to that effect. But I just wanted to make a note that it's different than what you've articulated in the and potentially could be different, and more discussion needs to happen to get clarity on exactly how these assessments are done in PJM and MI. So while they're complying with all NERC planning standards, it's not, nobody's trying to compromise that at any level, but it's just the way how they are done in terms of reliability versus deliverability assessment.
Yeah, well, take a look at their use of RAS as well, or their lack of the use of RAS compared to ours.
So, yeah,
Understood.
Robert, it's Neil. I was just going to chime in because I think Bhaskar, I really appreciate your comments, because I think a key word you emphasized was that there are nuances. And we would certainly agree that everybody has their own unique spin on this. But I think Robert's articulated that, the N-2 concerns, there can be a debate about, well, is someone slightly more stringent, or what nuances are they applying that someone else isn't? I think that's a very important word, is nuances. And as Robert indicated, there are other issues that are much more strict around not using RAS, not using congestion management, that would have a huge impact if we migrated to some of those other approaches. So there are differences there. At the end of the day, though, and this is what I wanted to raise at the end, so I was chiming in just because it feels like I do want to steer that we keep the door open for that conversation at the end. At the end of the day, we also appreciate that the impact the mitigations are having, even RAS, with the timelines associated with some of them, is a concern. And as Robert was suggesting, it's what are the ways to address this with everyone having the same overarching concern of what do we need to do to manage the maximum throughput of actually getting resources through our process and connected? Are there things we can, practices we could adopt without sacrificing what we believe are technical requirements? Are there other processes we could adopt on a risk-based process so that the mitigations are not disruptive, that they're addressed over time, and that we don't have an entire fleet in this situation at the same time? What are those other approaches we could take to address the concern? And I have to admit, at some point, I would actually, hope we could shift the conversation to that, as opposed to trying to find the lowest common denominator between everyone's existing methodologies, and say that that's how we should be planning and operating the system. Does that make sense?
I think it does, Neil. Thank you for, I think, the key words that you said about that, you want to clearly ensure that those mitigations are not disruptive, and we are not talking about the lowest common denominator. I think the N-2 is, maybe could have more discussion on that later on. But, we agree that you're required by to study the N-2 contingencies, and so are the other ISOs like MISO and PJM. We're just trying to see whether what they are doing probably in some cases would that make more sense in terms of getting all these resources that we need for resource adequacy purposes well in time, and see how that flushes out in terms of, I think you'll be talking later on about some risk-based mechanism for, I think we should definitely go ahead and do that for the urgency of matter. But then if that works, if we know that works, we want to be nimble in terms of, and I think the same thing goes about QC levels. We have seen historically that you have changed assumptions in terms of the PGen numbers, and as you get more data available and things change, I think you have changed deliverability methodology and the assumptions accordingly in the past. So we're just hoping that would continue as part of this discussion that we're having. Thank you.
Appreciate that, Pushkar. Appreciate it.
And then we have a question from Alexei Orkin with AES Clean Energy. Go ahead.
This is Alex Orkin from AES Clean Energy. And thank you for putting together this presentation and addressing this quite complex topic. And also, thank you for addressing our comments on the deliverability. But if you can go back to page 21, please. Yeah, so I just wanted to add a clarifying comment in regards to our previous comments because I was involved in formulating these. And basically, as a developer, we will definitely support relaxing N-2 requirements for interim deliverability since it would allow for more generators to come online and provide resource adequacy sooner. But as far as using N-2 for deliverability, you mentioned that TPL1 requires evaluating against N-2 contingencies. However, I was thinking that KAISA's evaluation of -2 criteria for deliverability goes beyond the way NERC planning standards evaluate N-2 contingency. And correct me if I'm wrong, but NERC standards were meant to verify that peak load can be served under N-2 conditions. So if you have a tower outage, it might not be recovered in time, so you still need to serve a load. However, when you add N-2 contingency to deliverability, you verify that this contingency does not curtail loads for primary system needs and secondary system needs. So it's not just able to serve the load at peak, that you're able to deliver renewable energy under these conditions for N-2. So I think it kind of goes beyond the NERC TPL standards. So just a small comment for your consideration. Thank you.
Yeah, I don't remember seeing it that black and white. My general understanding of the TPL1 standard is it's to ensure, the reliable operation of the transmission grid. Plan the transmission system so it can be reliably operated under, and like I was just reviewing the first part of it, it says under a wide range of system conditions. If you have blackouts and losing lots of generation, I think that's a concern of the NERC standards, even if you didn't lose any of the load right off the bat. But anyway.
And it's Neil here. I would just ask too that those comments also be added as well. So we'd really appreciate comments on these topics.
All right. Let's go ahead and move on to Dariush Sharmo-Hamadi. Thank you.
Thank you for pronouncing my last name so well. With Grid Bright on behalf of California Wind Energy Association. First of all, I want to make sure that there is clarity in what we said. We never said N-2 should not be used for interconnection studies. At no time we said that. You have reliability studies that rely on N-2, and they should be used. They should use N-2 contingencies for reliability studies. Our main point was related to deliverability study. So let's clarify that point. Then I'd like to ask a couple of questions. Does CAISO use the result of deliverability test methodology? Do you use these results for any operational purposes? In other words, do you operate the grid based on the dispatch and and contingencies that you use in your reliability assessment? I know your interconnection reliability test is similar to the way you operate the grid. The way you plan the grid is similar. You have a reasonable dispatch of system resources, a credible set of contingencies, and so on. So that is the way you operate the grid. This is the way you plan the grid and use it for interconnection studies. Do you operate the grid, plan the grid under any circumstances based on the dispatch and contingencies you consider in your deliverability studies?
It's Neil here. Want me to chime in on that, Robert?
Well, I'll bite my tongue. Go ahead.
Well, I would. Well, actually, if you want to chime in too, but I would just say off top, yes, when there's elevated risk, N-2 contingencies are not always activated in real-time operations, and many times they're not. As we said on the slide, when risk levels are not elevated, real-time operations are not activating those constraints. But when there is elevated risk for the N-2 event, there are decisions made in real time about the level of risk and whether or not to activate. And I think that was Robert's earlier point, was if we haven't planned for it, then operations don't have the option. So there are differences. The planning environment and what gets built defines what options are available in real time. And if an option isn't built and available, then it will never be used. So that, I think that's the short answer, is N-2s do get respected when there's elevated risk for the N-2. And that's something that I'll stop there. Robert, anything you wanted to tag on?
No, just this notion of, do we use deliverability studies to operate the system? And we're looking out in the future, so obviously we're not actually operating a system 5 years from now, but we are looking at what we believe are plausible stress system conditions that could be seen in operations 5 years from now.
Okay, so obviously, again, misquoted my point. Sorry to say that. I didn't ask for whether you consider N-2 or not. My question was the system dispatch that you use for deliverability studies, where you take a generation pocket, raise generation to 80% or 100% of the NQC, and all the generation everywhere else is reduced proportionally to have it matching between supply and demand, and then run the system. Do you, in fact, when it comes to operation of the system, do you operate the system based on such a dispatch?
Well, it's Neil here. I would answer that, Robert. I think I want to chime in because of the operational aspect here. Robert's talking about the planning and the interconnection studies, where we're often studying a significant number of resources in a particular area. And they're studying that area, one area at a time. And they're not elevating the entire grid to an extremely stressed condition and raising all generations simultaneously. But in operations, in each of the last 3 years, we have been pressed to the wall where all available resources have been getting dispatched to meet load. It happened in August in 2020, in July in 2021, and in September of last year. So, which is the purpose of the RA program, and to have the resources available. So I think that's a short answer.
That's an excellent point, by the way. That's an excellent point, and it applies to definitely apply. Whether for that system condition, well, the load is high enough, well, you need all the resources that are dispatchable at the time. For that condition, we completely see what you're saying. In other words, you're not maximizing resources only in one zone, but everywhere in the system to meet the demand. And that it's not like you maximize the resources in one zone and reduce all the generation everywhere else to such a low level so that you can accommodate the maximum generation in that zone. You're talking about a system condition where we need all the resources in the system, and I completely understand it. But this other condition that we reduce generation everywhere in the system and increase it to the max. What I was trying to say here is the application of the deliverability test methodology has been to certify whether a generator is qualified to provide RA capacity. It really does not have any application. In the application you are mentioning is captured in reliability runs. Reliability runs when we have barely enough resources to meet the demand, and of course everything is fully dispatched. for these other conditions that we run for, and if you are doing reliability tests that does not cover that condition, then there's something wrong. So when it comes to deliverability tests, the goal is to whether the resources that are come out of the deliverability test without being curtailed or turned off are eligible to provide RA capacity. And that takes me to the point where, is there any NERC, WEC regional planning standards that specifically talk to deliverability test methodology?
Well, Darius, I wanted to back up a little bit on the reliability studies. At least any reliability studies look at one snapshot, generally one particular generation, there's thousands of generators, and it studies one particular state of the system with 1,000 different states. It studies one possibility when there's, hundreds of thousands, millions of different possible conditions on the system that could be experienced when you're short on resources and you need everything. So there's no way 2 or 3 snapshots can capture that adequately. Essentially, you take you look at one possible scenario, you study that one, if you end up getting lucky enough to in your next resource shortage condition, and that happens to be the way all the resources are dispatched, because the ones that are not available you correctly had off in your study, and the ones that were you had on, yeah, that would be correct, but that's not probable. That's not going to be the case. So I would say, yes, the reliability studies do not adequately capture that, and that's why you do need more sophisticated tools than typically the reliability studies, at least like in the TPP reliability studies, and even in the GitApp reliability studies. Again, those we're typically not using sophisticated tools to do that, and because they are focusing on, we do several study areas and pretty much turning up the generation that's interconnecting up to its maximum capability to check and see if there's any problems. So I don't agree with your characterization that a typical reliability study covers that adequately.
And Robert, it's Neil. I'd just like to tag on that as we said at the beginning, or I said at the beginning, the purpose of our deliverability methodology is to test that the transmission system can reasonably, not 100%, but reasonably ensure that resource adequacy capacity can be delivered to load during stressed system conditions. That is the ball we have our eye on the deliverability methodology. So I just want to, I heard different articulations of what the purpose of the methodology and the RA program is, but that to us is the purpose. And I think, at this point, if people have comments they want to make about what the purpose of the deliverability methodology should be, I think we'd be happy to see that in your comments. So thank you.
Thank you.
All right, up next we have Shane O'Brien.
You guys hear me all right?
Now we can.
Okay, thank you. Just a quick comment, and I guess quick disclaimer, I'm a former MidCon and ISO employee, work for a developer now. But yeah, I mean, the MISO methodology around deliverability is based off of the, how the resources operate in a real-time environment. And so, similar to how they're maintaining, an N-1 dispatch in real-time operations, that's what their deliverability methodology is predicated upon. And so they don't look at N-2 contingencies in their deliverability analysis. And the reason for that is both the real-time operating standards as well as the transmission planning standards allow for curtailment of firm transmission service under N-2 conditions, including P7 conditions. And so that's the background of why that is the case. You know, we would agree generally with the comments that are here. We feel like the N-2 analysis in the deliverability study is you know, too severe conditions and is not adequately representing how the system is being operated and dispatched in real time. And then Robert, I guess the other thing I wanted to add for you too, because you had a question on this earlier, they do you know, a deterministic planning for the ERIS analysis. They don't do, I mean, they use Terra for the deliverability analysis and also the ERIS analysis, but they don't do a multitude of dispatches similar to the deliverability process for ERIS. It's just a static dispatch, deterministic style planning, just similar to how they do their annual TPL transmission planning analysis.
Yeah, no, I've studied it quite a bit, and I've talked to current MISO employees about it, and they do run N-2 contingencies in their reliability analysis. They do run some fairly stressed generation dispatch conditions, but yeah, this, as we stated, they do not run the N-2s in deliverability.
Okay, just want to make sure I was clear. It seemed like there was a little bit of confusion on that earlier.
Yeah, no, we had direct conversations with them and clarifying emails and things.
Mm-hmm. Okay.
All right. Up next, we have Susan Schneider.
Hi, Susan Schneider, Phoenix Consulting. I had more of a general question on slide 22, and there's several clients I have who took a look at this and said, "Wow, interim deliverability." We, you know, a lot of people have really have a great desire to know more about whether they might get interim deliverability before their upgrades are complete. Because, you know, I mean, you basically get some information on the ADNUs that could be problematic in phase one. Most projects then go and pick option A, and then they never see anything else about ADNUs until they get to the TPD allocation process. And even then, when they get an allocation, assuming that they do, they don't really get any information about which upgrades the allocation is based on. And it would be very helpful to know that at the time, because then they would know, for example, if one or more of those upgrades was 5 or 6 years ahead of, you know, after their COD, well, that may affect what they choose to do with their COD. And if they could know whether they might have interim deliverability before the year before they come online, which is the case now, that would hugely help them in contracting and, you know, knowing whether they were going to have issues with their PPAs, whether they could stay on their schedule, or just to be safe, if they, you know, do they have to then delay their COD and deprive the resource that would be available to the grid until the upgrade is finished, because they can't risk penalties under a PPA. So I wasn't sure if that was what you intended here, but this idea that interim deliverability service information could be provided well before the year before a project comes online, and that when they get their allocation, they would know the upgrades that they were depending on. That was sort of, those are exciting concepts, and I'm wondering if that's really what you intended to suggest here.
Yeah, it's Neil. I'll jump in on that, Robert. With the short answer is yes, Susan, and that's why it said some form, because we know our current interim deliverability service structure is wrapped around that nearer term projection. But this issue about taking more of a risk-based approach in assessing the risk of waiting for the N-2 requirement to be addressed and being able to decide earlier that maybe that doesn't need to be a barrier to the resource coming on and selling RA capacity while waiting for that mitigation to be put in place. We would like to see it put in place, but taking a bit more risk that this wouldn't be everywhere at the same time. that's why we called it some form of interim deliverability. And that's something we would like to explore. And that's kind of jumping ahead to my slides later about this is something we'd be interested in comments on. So the good news for all of you is I'm going to have to spend less time on my slide deck later because I've been jumping in now. But that is something we want to explore, what you're
Okay.
describing, and earlier
Okay.
than 6 months out. So not telling 6 months out, oh, by the way, we can wait for the RAS. That's not giving a lot of notice. We would need to be doing that earlier.
Right. Okay. And then, yeah, way earlier, in fact, maybe even when, and
Yes.
again, information when you get the allocation on what are you waiting for something that's 5 years ahead of your after your COD, or 2 years? It would be really important to know that, at least on the schedule. And I guess the other thing, and I'm not sure where that fits in here, maybe it doesn't really fit in this topic at all, but the RAS timelines seem to have just stretched way out. You know, when you're waiting 4 years for RAS, or a RAS, which isn't even, physical upgrades, it's like computers, that you're waiting longer for that than any physical upgrades, just seems ludicrous. So, I mean, if there's any, it's certainly troublesome. So if there's any, I don't know, again, I don't know where that fits in here, or if it even does, but that issue is a real critical one, where you're waiting around, all the upgrades can be physically finished, but you're waiting around for the RAS. That seems somewhat problematic. So I don't, anyway, wherever that can fit here, that would be a good thing to think about.
Susan, the issue about the timelines for some of these mitigations, I have to admit, I think that is actually the root here of the industry concern around us studying the N-2s at all, is that the mitigations they're not expensive. These are generally RAS or reconductoring are the vast majority of mitigations that we're talking about. The timelines are definitely a problem, and we appreciate that. So that's why we're wanting to consider what can we do that we think are still meeting our technical needs in the long term, but perhaps take a bit more risk on in the interim to avoid disrupting projects with these lengthy timelines, especially when these timelines suddenly get pushed out.
Right, and I think
I know we're all aware of those circumstances where a resource gets bad news relatively late in the game, that an upgrade, or especially a RAS upgrade that was expected imminently, has suddenly been pushed out. That's painful for the development community. It's painful for us too. So this is a real concern. So that's
I think they're not mutually. Yeah, sorry, I'm saying this will help. I mean, having this interim deliverability approach will definitely help. It doesn't take the place of the other concern either. But the idea, again, a reconductoring at least is a physical thing that you have to schedule, and you have workers, labor, whatever. A RAS, I mean, I know programmers are labor too, but anyway, it doesn't. I think what you're suggesting here will certainly help if people could get interim deliverability and know about it a lot sooner, and what it applies to, so the transparency is there. But that doesn't take away from the other thing that you were talking about, or that I was talking about, and you are, which is why do things like a RAS take so long, and why can't anyone stick to a timeline? So both are important, but this is as I said, this is exciting to think about, and we would like to definitely see more detail on it.
And thanks, Susan. And I would just want to reiterate that we referred to it as some form of interim deliverability. I don't want people to think our current interim deliverability service, with all the qualifiers, the way it's currently packaged, but that's it. This would need something sooner to be useful. So it needs, but that's the idea, is not finding a way to not let these upgrades, the timing of these upgrades, get in the way and disrupt project development. And that's been especially a concern when the mitigation projects get deferred and disrupt projects that are in flight.
Right.
We've got to find a way around that. And I'm not optimistic that it's going to get faster to make some of those changes. So I can hope for the best, but this is us trying to prepare for the worst, that those timings are a reality. and
Okay.
what can we do to mitigate?
Okay, well, definitely would be helpful. Yeah, don't give up on the other stuff either,
No,
but yeah, definitely would be helpful, and we really appreciate your taking a look at this. Would very, very strongly support it.
thank you.
Thanks.
All right, we have Aftab along with SB Energy.
Hi, everyone. Can you hear me?
Yes.
Hi, Robert. Hi, Neil. Just wanted
Hi.
to, thanks for the opportunity to provide comments. Just wanted to echo some of the earlier, comments about we probably need to spend more time on talking about the application of n-2s, in a deterministic way over here, because I think we would all agree that the problem over here is quite stochastic, right? It's a very probabilistic scenario that we are trying to figure out, what's the deliverable capacity out there. Yet, and some of the and there are elements of the stochastic approach being applied in the current methodology, right, where you're looking at least on the resources side, how much of that should be assumed to be online in the dispatch and whatnot. Yet on the contingencies front, it's a blanket deterministic application of putting in all the n-2s in there. And I also agree that we should like earlier it was being said that we cannot be not running any n-2, but running every n-2 is also the other end of the spectrum, right? So is there an opportunity to apply that stochastic approach even to the to the list of contingencies that are included in this analysis, and it could be based on the differences between the regions, like you were saying earlier, Robert, where there are obviously there are geographical and other variation between different regions, and maybe that could be the driver of how a stochastic set of contingencies is selected for the analysis, versus an extreme approach of applying every n-2 and leading to not having resources getting deliverability, that's delaying their commercialization and whatnot. So that's one. And I think there are other comments I have on applying that stochastic approach not only to contingency. I mean, earlier it was being said that all the resources had to come online on the peak day. I think Neil was mentioning that, and why was that? Was it because there were maybe forced outages on other resources? Maybe that is another, and maybe I'm jumping to other slides over here, but maybe that's another way you could apply some of the stochastic approaches to the current methodology, where it could be a middle ground approach, where you are finding some common ground between what we are trying to achieve, making sure we are reliable, also making sure that resources are able to come online earlier. So, and I'll include that in the comment. Just wanted to talk about it, see what your initial thoughts might be to having a stochastic approach even on the contingency set, especially the n-2s.
Yeah, well, the TPL1 doesn't really, if anything, it says make sure you study the worst n-2s. And you don't have to study them all, but generally you're supposed to study the worst ones. And so it's easier for us just to run them all, because if you're going to run the worst ones, what's the problem with running the ones that aren't a problem in the first place? Yeah, I mean, we can take a look at the comments.
And Robert, I just wanted to mention, just so that everyone hears that correctly, that when you're referring to all n-2s, it's only the common mode, basically double circuit tower outages we're talking about. One of the changes I mentioned a few years ago was no longer studying common right-of-way towers, right? So the all that you're referring to is all n-2 common mode, common tower circuits.
Yeah, thanks for that clarification. Yes, just the common tower circuits. Yeah, have a common tower for more than a mile, as a matter of fact. Yes.
Yeah. Right. Thank you.
All right, and I think we have our last question here from Tao Yang with GridBright. Go ahead.
Much. This is Tao. I work for Darius in GridBright, and I used to work in PJM for quite a few years. So just want to shed some lights about PJM methodology. I understand nuances, like Neil mentioned. I also understand the KSO system is different from PJM. So with that being said, I just want to point out, like Neil mentioned, what's the purpose of GenDeliv, right? So definitely the PJM generation deliverability's purpose is to ensure that every capacity megawatt can be delivered to every load, any load in the PJM system. That maybe sounds out of whack or too much stressful, but in another word, we can say it in a way that every transmission system equipment in PJM footprint should not be a limiting factor to any reasonable and possible transfer scenario. So this basically covers the reliability as well, that like Robert mentioned, that in the planning study, we most of the case we only study quote unquote the worst case, but it's not the worst case, is what we expected as the worst case. So that is why deliverability study in PJM covers not only capacity but energy. And that is the largest difference between the so-called as concept of deliverability in California ISO and PJM, because I would say it's different between MISO and PJM as well. So with that being said, to just share some nuances in the PJM methodology, the N-2, aka common mode, is applied to the maximum facility output of a generator, not to capacity only. So when we perform GenDeliv study, remember, I just want to make sure that we understand GenDeliv is just a studied methodology. When we talk about GenDeliv, it's not always the case that we talk about capacity only. So in California, so okay, we talk about generation deliverability, we know that it's for capacity only, that's fine. But if we would like to define our criteria in that way, then we should not consider, the impact of some other contingencies which may only be applicable to the maximum facility, which is capacity plus energy, such as what we have used in the TPL, whatever, special contingency or RAS schemes that we typically consider in the reliability study. That's obviously that's a large gap between the idea of those N-1 contingencies used and the common mode contingency used in delivery study. So with that being said, if we plan to move to include more N-2 contingency into the study, do we see a necessity of performing those type of study to the existing generation? The reason I'm asking is because it's always a common, I would say, a practice or rule we have to implement, that we treat the existing generator and the future generator using the same way. We cannot say, okay, because you are already here, so we guarantee your capacity, and for the new ones, new rule will be applied. That, and because of the criteria change, so the possibly the available capacity in the existing area is already not applicable because you have more contingency to be selected, right? So even for the existing generators may not have enough capacity based on the new criteria. So I'm not sure if that will be considered in the future if we move towards the direction of adding more contingencies into the criteria.
Well, I sort of gathered that the question seems to assume that we're proposing something new here where we would start to run N-2 contingencies, or did I just totally miss the question?
So I think there are two parts. Number one is that if we plan to apply, let's say, N-2 or multiple contingency, are we going to apply those contingencies to capacity only, or are we going to apply those contingencies to capacity plus energy? That's the first question. The second question is that if we plan to apply multiple facility contingency beyond P7, do we need to apply those methodology to the existing generation and identify required network upgrade before we apply those rules to the newly requested generation requests? Hope that's clear.
I think so. So what I've been talking about is what we've been doing for basically 15 years plus. And so we have been running these N-2s, but, and I think part of your question is, are you running more than just the double circuit tower lines? And for the most part, we're just looking at the double circuit tower lines in the studies. And I think that might have been one of your questions. And then you talked about, oh, go ahead.
Sorry. Yeah. Okay, Robert, I was just going to add on that the question about how do you study the existing fleet, I think there the point, the reason I jumped in was, and I apologize for that, Robert, was I just wanted to mention that at the beginning I mentioned that the large area network upgrades are also assessed through the annual transmission planning process. And that as well is where this criteria, the deliverability methodology is used to assess based on not individual interconnection requests, but based on the renewable generation portfolios that are being planned through the Public Utilities Commission process. We're assessing the requirements and impacts using the same deliverability methodology in the long-term transmission planning process for both the existing and forecast resources to meet these deliverability requirements. And that's where the policy-driven transmission comes from, is assessing existing and planned resource fleets on a zonal basis. So this isn't just something that gets applied to new resources that are applying in our interconnection queue. It's also applied on a system-wide basis in the annual planning process. So sorry, Robert, for cutting in, but I just wanted to tie back to my earlier slide on that.
Thank you very much. Thank you very much.
And then Robert, I cut you off. You were going to answer the other part of the question.
Well, I was going to touch on that as well, but and I don't know if there was any more to answer. Sounds like we answered his question.
Thank you. Thank you very much.
All right. Well, that is all we have for questions. If you want to continue on.
Yeah, please. Next slide, please. So, moving on from the N-2 and different entity comparisons, another concern was the simultaneous dispatch of generation in the study, and I think Neil probably touched on this already, but so the process is intended to test the ability of a group of resources to be dispatched at full output when various resources outside the study area are unavailable. And as we got into the discussion earlier in response to questions, there's just many possibilities that where resources can be forced out during this resource shortage condition, and so there's just almost an infinite number of possibilities, and so that's why we're studying groups of resources at a time to sort of address all those possible system conditions. Because you can't just pick one condition, study that, and say, oh, I guess that works for everything. So anyway, it's intended just the testability of a group of resources to be dispatched at full output. And it's a reasonably sized group. I didn't get into the details, and we turn up 20 units and that sort of thing. But that is in the posted methodology. So with that sort of little bit of background, one of the comments we got from BAMX stated that generation dispatch should realistically represent their expected levels of operation and should not necessarily assume simultaneous operation at their qualifying capacity level, as assumed in the ISO's deliverability assessment. Again, this is a little bit of a rehash of what we've already covered, but during these resource shortage conditions, all available resources will be needed to simultaneously serve all the firm load, and so that is the condition that needs to be studied. You certainly don't want to have resources that are available and ready to produce megawatts only to be constrained by the transmission system. Practically all the resource planning analysis assumes, pretty much at least on a fairly wide range, wide area basis, and an infinite transmission system. They don't assume any transmission constraints. And then the most recent events of September 6th and other heat wave days in 2021 and 2020 have just reinforced recently the need for RA resources to be capable of simultaneously providing needed capacity under these stress system conditions. So I made a note to see if there's any questions, although I think we already covered this, but are there any questions? If not, we can move on to the next slide. Okay, so another concern, AES Clean Energy stated that the studied deliverability capacity often exceeds the local load within the study area and often results in inaccurate network upgrade requirements. But from our perspective, this concern is addressed by the area and local deliverability constraint framework that we have in the GitApp tariff language and in the process that we've been following for several years. In this framework, transmission constraints that are identified in the deliverability study, those transmission constraints are then classified into two buckets. We have the area deliverability constraint bucket and the local deliverability constraint bucket, if you will. Constraints with large amounts of generation and behind them that trigger large high-cost network upgrades are classified as area constraints. And because upgrades are not required for area constraints in GitApp, this avoids the identification of excessive delivery network upgrades for the most part. Next slide, please. So a little bit of a similar issue, I think, although I think more on the cost. BAMX stated that expensive transmission upgrades had been deemed necessary by the ISO to make projects deliverable. And the ISO should not sanction the transmission planning and generation interconnection process where the underlying theme seems to be deliverability at any cost. So as a reminder, the generation interconnection and transmission planning processes are coordinated. And they're also coordinated with the CPUC's IRP process, their integrated resource planning process. And high-cost delivery network upgrades are developed through this coordinated transmission process that considers the cost of transmission and the development of the resource portfolios. And then just as a data point, for the 9 years between 2012 and 2021, there were very few policy-driven transmission projects were identified for the purpose of deliverability. So that really kind of doesn't support the idea that we're just building transmission willy-nilly with this approach. Anyway, are there any questions on that?
Yeah, we do have a question from Alexi Orkin with AES Clean Energy. Go ahead.
Hi, Robert. I realize we're running late, so I'll try to make it quick. If you can go back on page 24, please. I just wanted to provide additional clarifying comments because I think our original comments might not have been as clear as they should have been. But basically what we're trying to say here, for example, for San Diego area, we noticed some constraints like St. Louis rates to San Onofre area deliverability constraints. The overload is from San Luis Rey to San Onofre. So that's more or less away from the load center. And I think what's happening here is you have so much capacity in the queue that it's not an issue of getting that capacity to the load center. It's just there's so much capacity that's being studied that you more or less serve the load, and but there's not enough load model, so you get overload in the opposite direction more or less. And I think maybe it doesn't really make sense for these type of constraints to limit deliverability. And with cluster 15, you're going to have even more capacity in the queue, so you're going to have even more overloads where you don't really. It's not natural to have overload. It's not in the direction from the generation source to the load center, but in the direction opposite of the load center. So that's kind of our comment, and we'll submit additional clarifying comments on that.
Yeah, thanks for that clarification and the specific example of St. Louis Rey to San Onofre. So you know, tying it back to the point I was trying to make, that is an area constraint. So we're not requiring the generators to fund upgrades, but you're right, it does limit their deliverability allocation. You know, just as a side note, we did approve a project to address that constraint last month. It will take it a while to get it in service. But the other point is, I think we covered it in the slide as well. So San Diego is a load center. In fact, it's a local capacity area. And so this question kind of gets to, well, why can't I just be deliverable to the San Diego load and forget about the rest of the ISO load? And so that and I'll talk about this later. Neil already talked about it. And in fact, ultimately, this is beyond the scope of this discussion on deliverability, because as Neil mentioned, that could result in two different products, you know, like a local deliverability and a system deliverability or something. But anyway, you know, San Diego is a load center, but there's a much bigger load center just a little bit north of Songs there. And we're trying to make sure these resources are deliverable to the aggregate of ISO load. And I think I have a slide on this as well, at least somewhat. And so it's not like there's no load for hundreds of miles. There's a huge, you know, the biggest load center in, you know, west of New York City is pretty much not far north of Songs. So anyway, it's not surprising that if you put in a bunch of generation down there and we're trying to make it deliverable just to the aggregate ISO load, that you might see a constraint from San Luis Rey to Songs. Anyway, those are just my thoughts on that. I'm not sure you had any questions actually, but any other questions?
Oh, no, I was just wondering about that. To me, it seems a little bit of unreasonable dispatch, because under that scenario, none of the renewable generation in LA are going to be contributing. So anyways, we might submit additional comments, but thank you for the explanation. We appreciate it.
All right, and then we do have one more question from Pushkar Wagle with Flynn Resource Consultants.
No, but just to make it very brief, we are running really looks like short on time. So although between, I guess, 2012, last decade or so, very few policy-driven transmissions were identified for the purpose of deliverability in the last, we can see in last 2 years planning cycle, we have about 7 billion of them that's been approved. Clearly not considering some of the projects that would be approved as an extension of the last year's planning cycle. But we note that there are several transmission network upgrades that were identified as needed based on the CAISO interconnection agreement that were also based on the deliverability assessment in the 2010-11 timeframe, because we are old enough to remember all that now. But we do recognize that these upgrades are driven by tremendous resource needs for the climate change goals as well as escalating load forecasts. So we are nowhere claiming that we're willy-nilly approving this transmission. We recognize that many of them are needed. We are just questioning whether some of that need is also exacerbated by certain assumptions that are made in the deliverability assessment. And we'll put some examples. You know, when we want to be realistic, we don't want to overblow certain assumptions that we are making. Means we can see, for instance, that the HSN is clearly more binding than SSN in many scenarios. But there are certain cases like south of Mesa corridor deliverability constraint that we saw last time in the Lugo Victor Kramer, where SSN is more binding than HSN. Or if you look at the N-2 kind of contingencies, we can see that clearly not all of them are driven by N-2, but there are certain transmission projects, like the Lugo Victor Kramer, we could see that P7 was the primary driver for those kind of specific projects. So that's exactly where we are talking about, but we want to be reasonable in terms of what our expectations are and what sort of assumptions are clearly driving certain things that you don't end up with some unnecessary or underutilized transmission assets.
Yeah, so certainly there have been some projects identified as needed in 2022, but the portfolios have just dramatically exploded over that time period. So it's not surprising. And it just kind of reminds me of, we had a pretty good rain year this year. So So does that mean that you know, California is a tropical state? No, I mean it's still we still had a drought almost kind of between 2012 and 2021. We kind of had a drought as well. But so the point being that, you know, sometimes you have a little more projects, but if you go 9 years with no projects at all, and then you know, I think that's certainly something you have to take into account is are we using methodologies that are driving unnecessary transmission projects? Well, for 9 years, they were driving almost nothing. And there was some growth in the portfolio. We went from like, you know, the 20% RPS up to, you know, beyond 33%, you know, actually beyond 50%. And we pretty much lived off the system for 9 years. So definitely need to be mindful of that.
Sure, no, especially because of the fact that we have so much now in portfolios, and the goals are pretty aggressive. I think it is even more you know, we need to pay a little bit more closer attention to what exactly that we need for sure as the things progress, because these are very long lead time resources and so on anyway. But yeah, your point well taken, but I hope you understand where we are coming from. In terms of, we are not claiming here that all those projects are clearly driven by this methodology, but there are certain assumptions that might be tilting it one way versus another, and you may want to closely inspect those assumptions. Thank you.
All right, well, that's all we have for questions at this time.
Okay, next slide. So as previously mentioned, the deliverability assessment is performed under two distinct system conditions, the highest system need scenario and the secondary system need scenario. With the growing complexity of the resource fleet, you know, as we've discussed, the CPUC is looking at a 24-hour slice of day approach for RA purposes. And the SSN study focuses on the transition between when the gross load is still high and the solar production is dropping off. And as I mentioned, resource shortage is less likely, but it still could occur based on some analysis we've done not too long ago. And so then with that kind of recap, you know, we got a comment from BAMX indicating that if the expected storage discharge behavior is properly modeled, then the SSN assessment should not identify more upgrades than the HSN assessment. And so in response to that, you know, the storage modeling in the SSN assessments are based on recent historical storage discharging information provided by the ISO in last year's stakeholder process. So it is based on, you know, realistic, real information. And also, for the most part, as we've said, with the new adjustment, the SSN results are less severe than the HSN results, almost always. So it's probably enough on the SSN study. Are there any more questions on the SSN study?
No, I don't see any.
Okay, next slide. So the California Energy Storage Alliance asked whether N-2 contingency should be mitigated in the transmission planning process instead of the generation interconnection process. And BAMX provided, at least from what I interpreted, a similar comment in suggesting that the transmission economic analysis and methodology, which we use in our TPP, should be used to determine when N-2 contingencies need an upgrade. As mentioned before, the generation interconnection and transmission planning processes are coordinated. And the decision to build most delivery network upgrades is actually not made in the GitApp, and deliverability is allocated only up to the capability of the transmission system that is currently planned. However, ignoring the impact of N-2 contingencies in GitApp would lead to potentially higher ratepayer costs. And this is because in the planning and procurement of new resources, the full set of transmission upgrades, the full build out of transmission needed for that portfolio, or at least in the procurement, and you know, those upgrades identified in the GitApp, that information is needed to be considered in the procurement process in order to minimize the cost of ratepayers. If it's not considered in the procurement, you know, we could procure resources and then find out later we need some transmission that wasn't factored in, that perhaps we should have chosen some different resources because we didn't have the cost at the time. That's just the concern of not addressing the needs in the get app and just shifting it to the TPP. Are there any questions on that?
Yeah, it looks like we have a question from Doug Karpa with Peninsula Clean Energy. Go ahead.
Yeah, I apologize. Actually, I slow off the mark. I was thinking about the prior slide and, thinking about the SSN and like supplemental studies. As I'm thinking through this, I realize that a lot of this is looking at when there are, basically load is operating that is high enough to sort of be eating into the margin, and our margins are low. And I know there's a lot of focus around, obviously like net peak and peak. That makes sense in the current mode. And particularly one of the thought that kind of kicked off here is thinking about the slice of day, and particularly because at Peninsula Clean Energy, we're moving to 100% renewable energy in all hours. It makes so the question is this: shouldn't we be considering, instead of sort of the relationship between load and total generation, instead those hours where congestion specifically is a problem? And what's behind that question is, in our own modeling, like we see the real crunch time that's coming is going to be like 3 in the morning in February, when solar generation is just generally kind of cruddy, wind isn't too awesome, and we're having to charge a lot of storage, and we're really going to be running into energy constraints and charging the storage to meet that overnight load. That's going to be a situation where, like, yeah, the available capacity is going to be pretty close to what the load is, but they're both going to be really low relative to what the transmission system can deliver. Like, congestion is not going to be an issue there. And so at some point, if we stay focused on like when our margin's low, we're going to bump into periods where, yeah, margins are low, but congestion is just not the problem. It's just that we don't have enough solar, and there's not going to be any risk that something like won't be able to deliver. And so that kind of thinking makes me think that really the hours we need to be focusing on is when do we have N-2 contingencies? How often do they occur? So I cycle back to that. But also, when is congestion actually a problem for delivering resources? I know.
So I may have lost a little track of that, but
which I don't blame you for.
When you say when margins are low, you're saying, I use the term unloaded capacity margin. So you're saying we should be studying deliverability when the unloaded capacity margin is low? Is that what you're saying?
Rather, I think that the hours when that is low is going to lead us to studying some hours when there isn't really a deliverability issue. Because, now again, this may just betray my ignorance about how this whole thing works. My understanding is that what we're really looking at currently are periods when, like, for example, load's really high, generation's really high and straining. We've got a stressed conditions. Under those conditions, the transmission system is also struggling at the same time, because both load's really high and generation is just barely higher. But there are going to be cases where those margins are going to be low, but the transmission system's doing fine, because load might be low, but generation, if it's also low, we'll run into stressed, quote unquote, stressed conditions, but everything's going to have no problem delivering, because there's just tons of excess transmission capacity when both numbers are low, but relatively are close. Is that? And maybe this is like too much of a 2030s problem to be thinking about right now, but
yeah, so I was kind of expecting you to say when load is low and you have lots of generation, but you have a lot of congestion, we should be focused on that. But it sounds like you're not saying that, and that's good, because that is definitely not the purpose of this study. Again, the purpose of this study, I think Neil said it, and I probably repeated it, is when we are about to shed load because we don't have enough resources, We want to do the best we can to make sure that all the available resources are not constrained by the transmission system, and that is when the margins are low. Now, if the transmission system is fully capable of delivering all that generation, great. Well, then you pass the deliverability test and there's no transmission upgrades needed. If you have terrible congestion in the spring when the sun is really high, and you're trying to sell that power a long ways away or something, that's not the focus of this study. As long as you have enough resources to serve the load and you have a bunch of congestion costs, that's an economic study that we take care of in the transmission planning process, are economically driven transmission projects.
Robert, it's Neil here. I was just wanting to jump in that this is the first of the items I wanted to review after we got through all the, I'll say, the content discussion, which was that, but I'll spend a minute on it now though and simplify later. This is an issue we were actually looking for feedback on. Is Robert articulated why we study the high system need, and the secondary system need was created a few years ago to study that transition point when we're still expecting output from the renewables, but their output is dropping off. In that transition, and we're calling on a different fleet to step up and backfill as the solar resources drop away, can we get that declining solar output and those other resources to work together to serve load? That's kind of the secondary system need. And that seemed like a reasonable concern at the time. And what we're asking now actually in this process is, when we look at the additional complexity of the fleet going forward, and the CPUC's response to managing those concerns is migrating to a 24-hour slice of day process for the RA, are there other scenarios that are actually more difficult that we should also be looking at? So we know why we're studying secondary system need today, but is it the right condition? Are there other conditions? And that's where we're looking for input. So really appreciate you putting some thought into this and providing some comments about the scenario you're concerned about. We'd like to hear that out and take that into consideration.
Great, thanks. No, that's super helpful. Thank you.
Shouldn't we put a little bit of guardrails on that and make sure it's at least somewhat associated with resource adequacy?
Oh, yes. So the whole point is, I agree, Robert. Yeah, in terms of the reliability aspect of serving load under stress system conditions and accessing resources. So yeah, if Robert was talking about economic congestion and so on, that's not the topic here. This is about, are there other scenarios where we need to be concerned that we have adequate transmission to get the resources that we are counting on at that time and have to count on at that time to get them to load. Robert, I think that was your concern, that I was leaving it too open-ended. Thanks for jumping in on that.
Like I might have as well. So.
And the good news is I've just addressed slide 36, so I can cross that off.
Great.
Any more questions on this slide?
Yeah, we have two more. The first one being from Dariush. Go ahead.
So this is Dariush Shilmamadi, representing Calvia. Thanks for Neil. Thanks for articulating that and that's also Robert for articulating when deliverability assessment matters. That's when we need all the resources in the system and to be available, reachable to the demand. Of course, eventually the result of your study principally is used in RA program to see whether these resources add up to peak load plus 15 to 20% above peak load. So there will be a lot of additional resources available. But in your assessment, you focus on making sure all the resources you're studying can reach the load. And in that sense, deliverability effectively only matters when there is the possibility of loss of load. And we couldn't agree more with that. And in fact, anywhere that they test deliverability, effectively, some RTOs they have one test for that scenario that that there's a fear of loss of load. There's a concern about loss of loads because all the resources, at least are online, in the deliverability test, need to reach the demand. Of course, in RA program, we have additional 20% of resources in the system lying around. So, do you know of any other entity, given that background, and I assume is that the reason that, from my understanding, that no other entity but CAISO has an SSN test? That only they focus on the system condition where there is the highest chance or a real chance of loss of load. Your recent studies showed the time period that now you have expanded to for SSN, that you have expanded to cover hour ending 18. There is no loss of load probability there. Most of the loss of load is concerns are with HSN hours. Is there any other entity you know of who uses two tests for on-peak deliverability?
But Dariush, it's Neil. I think that's a bit of a loaded question because the obvious concern is I'm not aware of anyone juggling our current fleet of aggressive redeployment of solar, storage, and other intermittent resources to provide reliability. Robert, I'll turn it over to you.
No, I was going to say something like that, but not. You said it much better than I would have said it. So, yeah, I mean, you're comparing apples and oranges, I think.
No, I was just wondering because I understood it, and I heard from you guys as well that the deliverability test should apply for the case where there's a loss of load probability, shortage of capacity possibility, and based on your own studies, not performed by CAISO itself, the shortage of capacity happening during HSN hours. So I was wondering if that was the criteria, and probably that explains why nobody else does repeat this test during SSN period. But CAISO is repeating the test during SSN period, even though your studies do not show probability of loss of load during SSN hours.
Well, another thing to point out is most likely all the other entities have their peak load during the SSN hour. So actually, nobody else does an HSN study would be, I think, more accurate. Who else has a peak load at 8 p.m. at night or hour, whatever time it is, hour 18, I guess, 19, 7 p.m. at night. Most of them have their peak loads, well, either in the winter or sometimes, but they're usually earlier in the day, which again just gets back to Neil's point, is that nobody has similar situation.
Okay, thank you.
All right, and then our last question is from Pushkar. Go ahead.
Hello, but this is Pushkar. Can you hear me?
Yeah.
Yeah. I think regarding the economic assessment, and so we have seen that the QC values and the discussion that we had earlier in terms of how that deviates from your generation level values from the QC. But the concern seems to be about some congestion and renewable curtailment to a certain extent, from what I heard earlier. And so we were saying that in our opinion that can be handled as a part of a practical economic assessment to address increasing level of generation curtailments due to congestion. And it's important to note that that curtailment is not an RA issue for deliverability assessment, for which deliverability assessment design is more sort of an economic issue. But we could, I get your point in terms of we could have some detailed discussion about how and whether waiting to mitigate those transmission constraints in the TPP instead of identifying them in the generation interconnection process, whether that would result in delaying the development of transmission upgrades for multiple. If that's the concern, I think we can have some productive conversation on that. But we were essentially thinking that it's to me it looks like part of it is a more sort of an economic issue rather than RA issue, and whether probably the economic assessment is the right forum to address those especially since most of this deliverability is dependent on the ADNUs that are identified as part of the TPP anyway. Okay.
Yeah, I guess yeah, we did acknowledge that it is the ADNU framework, but if you don't at least identify that there is a constraint in the GitApp, generators will just move forward and get procured, and now you triggered a transmission project that you didn't expect, essentially, and it could be very expensive.
Understood. Thank you.
All right, that's all we have for questions.
Okay, so a different issue came up, and this has actually already come up a little bit on local capacity deliverability versus system deliverability, I guess. So Cal, we have provided a comment actually that appeared to suggest that the ISO deliverability methodology requires almost like point-to-point delivery of LA basin storage all the way to the San Francisco Bay Area. And just to address that is just not true. Generation only needs to be deliverable, only needs to be exported out of, and we post these area constraint maps, and so we have the diagrams of where the constraints are. And essentially, if you look at those diagrams, generation inside those constrained areas just needs to be deliverable past the constraint outside that little area. None of those diagrams cover the LA basin all the way up to the San Francisco Bay Area or anything like that. So they're fairly localized little constraints, and it's just trying to deliver the generation out of that generation pocket so it can isn't constrained in getting to the aggregate of ISO load across the ISO balancing area, but not to any particular load. Anyway, so LSA suggested that the ISO consider some portion of the LCR requirement could be satisfied by resources passing a test to be deliverable only to their local capacity area. And I guess I already said this, but the goal of the deliverability study is to determine if the aggregate of available generation output in a given area can be simultaneously delivered to the remainder of the ISO balancing area during a resource shortage condition. And essentially, we apply the same deliverability of a test to generation inside a local capacity area as we apply that same test to generation that's not inside local capacity area. So we apply the same test to all generation across the ISO area. And so the next slide might help sort of describe this. So this is an illustration of an existing generator that is behind a constraint, kind of shown by that dashed line there. It's deliverable, but it's only deliverable because some of its power is actually getting kind of flowing to that local capacity area, as you can see to the left there. And so not all of it's flowing across the constraint. If a new generator is then added to that local capacity area, well, more of that existing generator's power is going to have to flow across the constraint, and so therefore some of that generation will not be deliverable. But anyway, this gets into this two-product issue, and so this issue will be explored in the ISO's resource adequacy initiative, as I think Neil will talk about that. So, well, let's see, did I have any more on that? Probably not. Don't need to have questions on that one. That we're kind of punting that one anyway. Next slide, please. So this is about the NQC versus the exceedance space study amounts. Cal, we have stated that the ISO's current practice of using values that exceed current QCs for resources requesting deliverability is inappropriate because the system is designed to rely only on the NQC, not to meet the peak demand during the operating conditions the ISO studies. However, the generation dispatch assumptions in the deliverability study, they were described above. And the solar study amounts in the HSN study are at 10% of nameplate, which is actually lower than the NQC values during the summer months. And the SSN solar study amounts are, they're fairly reasonable for the time period that they represent. And with the recent modification to that study, it's almost, it's almost always less binding than the HSN study. The wind study amounts, so I'll cover that on the next slide. Next slide, please. So, although the HSN wind study amounts are higher than the NQC, wind production levels are variable. We talked about this earlier, so it'll be a little bit of a rehash. So on a particular day, the wind generation in, let's just say you have area A and area B, they're two geographically different locations. And so on that day, the wind generation in area A may be producing higher than their NQC levels, while the wind generation in area B is not producing anything. The NQC value is generally based on the aggregate production of both those areas combined as sort of a fleet. And so if the wind generation in area A had to be curtailed to its NQC value, because there's only enough transmission to make its NQC value deliverable, or there's a transmission constraint because we only built enough transmission to deliver the NQC value, well, then the actual generation production of the wind generation in area A is not going to be as much as it's able to produce, and area B is producing nothing. And so essentially the actual generation production of area A and B would be less than their combined NQC values because of this transmission constraint. The NQC values were assuming basically no transmission constraints, and so they came up with a particular value for that wind generation, but once you have the transmission constraint, they're not producing as much as you were expecting, and so your NQC value is not valid anymore. So this is why the ISO does not simply study the NQC values for wind generation. So are there any questions on that? Or any more questions?
Yeah, we do have a couple questions. Let's go to Susan Schneider with Phoenix Consulting.
Hi, Robert. Unfortunately, I do have a question on this local capacity issue on slides 28 and 29. So you mentioned, and the CAISO's mentioned several times, that this would be considered in the RA Enhancements Initiative. I covered the RA Enhancements Initiative meeting on Monday, and there was a whole lot of discussion about slice of the day and that sort of thing, but and a lot of other topics, but not that topic. So is there some timeline or plan or any way to get that topic into anything having to do with the RA Enhancements Initiative?
Looking at Neil.
It's Neil here. So we have raised this and agreed with the RA team that it does need to be added. I don't think it had been included yet, but this issue of creating separate products that would require LSCs to arrange their local capacity requirements and system capacity requirements and track them as two separate categories. We've raised that with the ISO RA team. I've been in discussion with Anna McKenna on the need for that issue to transition because it's a much bigger policy discussion around how resources would be tracked, managed, accounted for to accommodate resources that are only local capacity. So, like I said, it's a major issue to take on, and they'll be exploring that in the program. But I don't think they had time to fold it in yet. But that's where we're at.
Okay, so there's no timeline or plans or schedule or anything for that.
Not a schedule right now for it that I'm aware of. No.
Okay, thank you.
All right, and then our last question from Darius Sharma Hamadi.
It's getting better every round, Kathleen. Thank you.
Thank you.
So let's go to slide 28. Okay. So during the phase 1 study of cluster 11 and 12, when for the deliverability study, you were assuming south to north flows on path 26, a bunch of storage resources in the heart of LA Basin were told that they could not get deliverability unless the resources, under option A, unless some of the resources in the south will go away. Because there will be overloads on path 26 from LA Basin from Southern California to Northern California. So since the flow was going to meet the needs of Northern California and a resource in LA Basin was tied to overload on path 26. By the way, these are available in your study reports. We can show them to you if you want to. And since San Francisco Bay Area was the main hub of load in Northern California, this example was used for. We don't know whether it was consumed in Fresno or in Kern or in Bay Area, but it was coming. The resources in the LA Basin were not getting deliverability because they were overloading path 26 going north, and these were reflected in your own area studies that you can see for phase 1 of cluster 11 and 12. So just that wanted to for you to know where the code came from, and that is clear. Just to set the record straight. So the other point that we wanted to talk about is slide maybe 30. It was where you have.
Before you move on to another one, because I have a short memory. So yeah, I mean, first of all, the cluster 11 and 12 was not actually path 26. It was some Tehachapi area constraints, I think. It was probably the common corridor outages, which, as Neil mentioned, we don't look at those anymore anyway. But typically, we do try and set path 26, so it will not constrain, and we don't address that in the deliverability methodology. In that particular situation, path 26 was not the constraint. I think it was a common corridor 500 kV outage, again, which we don't look at anymore, but it did overload some facility in the Tehachapi, basically, north of Vincent. But it wasn't actually the 3 lines going into Midway, which I think is the definition of path 26. But anyway, and path 26 is, even if it was, is hardly the San Francisco Bay Area. There's a lot of good people that live in Northern California that are in the San Francisco Bay Area, and probably would take offense if you said they live in the San Francisco Bay Area. But anyway.
It was. I must admit, it was on when I said path. I just wanted to simplify the presentation. It was on the 500 kV path north of Vincent towards Midway, and generally we call it path 26. But nevertheless, it was a resource in the LA Basin, and we saw that the overload was happening on the path between Southern and Northern California. And that's where, and since Northern California is now a lump with load everywhere, including Bay Area, that was used for effect. But let's go to.
And like I said, because basically every generator, and even on those 500 kV lines north of Vincent during that that common corridor outage, again, which we don't look at anymore because the criteria changed, we intentionally keep path 26. So it will not be the constraint, because we know that every generator south of path 26 is going to get involved in that constraint. So we intentionally avoid that from being a constraint, which means we're leaving ourselves exposed to possibly having path 26 issues. But we hope the procurement process will be balanced north and south, and then we hope it'll get taken care of in TPP. So that. For better or for worse, we do end up deferring path 26 issues to the TPP.
Thank you. Thanks for clarification. So on all right, on the NQC issue, we can probably have a discussion around that and show you ample examples why what you're studying it at capacities beyond NQC. While it may have it may be critical for transmission planning purposes and so on, in the way that it reflects on a resource getting deliverability eligibility to provide RA capacity, it doesn't work quite right. So we have probably very simple examples that we could discuss it. Maybe definitely today is not the right forum for me to show examples, but we probably should have discussions around that point and maybe come to a reasonable arrangement as to whether QC of a resource should be used or some exceedance number based on some that number percentage that I wonder how you came up with 20% or for HSN and 50% for SSN. Was that based on some historical studies? So why those numbers were used and why those numbers may not be applicable for the purpose of giving a generator the eligibility to provide RA capacity. Maybe it has other purposes, but since your results are used for that purpose, maybe that's where we need to find a common ground where the right number should be, or maybe the recommendation should be your studies should not be used for depriving a generator from providing RA capacity.
Yeah, so as I mentioned earlier, those numbers are pretty much design values. The concept being that when we have a resource shortage condition and we have a particular generation area, group of generators that are available during that condition, we would like that group of generators to be deliverable at least 80% of the time. So it's pretty much, at least for the HSN. For the SSN, we were, less aggressive, and we just said they need to be deliverable 50% of the time during those conditions. But they're pretty much just design values.
And the 80% and 50%, just the design value you came up with, not based on any. And also, if the resources.
Well, the 20% actually kind of, we saw that's what PJM was doing actually. Okay. They were looking, their design value was, they're trying to look at, the probability of, 20% of the time, or basically 80% of the time, the resources should be deliverable during these conditions. And 20%, you could, basically, I guess it's kind of the old 80-20 rule. But that's essentially what we saw PJM was doing. And that's, if you read the methodology paper, it's kind of where the 20 units comes from. It just happens to be a coincidence that 20 units and 20%, but it is kind of an embedded design criteria in the methodology that we saw what PJM was doing, and it got carried over into this HSN.
And if we can show that PJM and MISO use actually the ELCC of a resource or its QC of a resource for the deliverability study, would that be sufficient to say that at least the 20% number that you somehow got from, you assume you got from PJM, I guess at the time you were both at CAISO when these numbers came from PJM, when that maybe those numbers are maybe not valid anymore, and maybe if both PJM and MISO show that they're using the QC number of resources.
Well, again, they don't have near the renewable solar and wind, certainly not the solar penetration that California has. And again, it was just that the 20% is used in a slightly different context at PJM, but I was just admitting that that's where we, at least in my part in the development of that, that was the reason I was posing that, and then we ended up adopting that within the ISO. But I understand that PJM details and nuances are different. But it does still seem reasonable that, again, because all the RA analysis assumes that there is no transmission constraint. And as soon as these resources are not constrained by the transmission 100% of the time, unless you get into big zones, then there is some sort of zonal constraints, but there's no local transmission constraints. It assumes the euphemism, the copper plate, infinite transmission system. So we're saying we're not trying to go that far, but we're at least saying 80% of the time the transmission should be adequate.
Thank you.
All right, and then we did just get a quick question in the chat from Ed Smeloff. The 80% and 50% are availability factors for the resources rather than an exceedance value, correct?
No, we're getting out of the context, but no, they are the exceedance values in the HSN and the SSN that was covered earlier.
All right, well, that's all we have for questions.
Good, and we're out of time. I guess the meeting's over.
Robert, it's Neil here. I was going to propose that I think you were also just going to be entering into your off-peak deliverability slides. I'm not actually aware of a lot of controversy around people submitting comments on it. I would suggest we use that we run over a bit here, maybe 10, 15 minutes. I just run through those wrap-up slides where we definitely do have issues people want to provide input on. That seems like a reasonable thing to do.
It seems like to me.
Maybe we could just ask right now if there were people that had questions about the off-peak deliverability that they really needed to have addressed now, or if they wanted to just submit their comments. We could just let it be open for a bit.
I'm not seeing anything come up in the chat. No hands raised.
Okay, so let's do it that way. Let's jump ahead to I'll say the review of the key issues that all did focus on the on-peak deliverability issues. And just to provide some context, and then we can probably wrap up and get people on their way. I think the good news is that, well, it was hard on Robert, me jumping in quite a bit through his deck, that we did hit a lot of the key points that I was expecting to actually circle back on these slides. If we could move to the next one. So I mentioned slide 36. I feel like we've already touched on this about the stress system conditions, that's the purpose of the test. That was a transitional step that we were looking at. If we're reliable at 3 and we're reliable at 6, can we get from 3 to 6 and deliver the resources that are being counted on? We've heard people raise other potential concerns around the conditions that the transmission system would be called on to move power around during these stress system conditions. And this is not about economic congestion. This is about, can we get those resources to play the part that they're being counted on at particular times of day to keep the system, to keep the lights on. So looking for comments on this, we do see this as an item that needs more discussion, and we'd really be interested in what people have to offer on it. Maybe we could move to the next slide, please. Obviously, there was a lot of discussion on the N-2 common tower contingencies. Wanted to reinforce that this is just down to common towers. We do see it needing one way or the other to plan for mitigating. We have concerns about leaving the mitigation to the transmission planning process. But I expect we'll receive comments on that. I really wanted to reiterate that we appreciate the concerns around the schedule delays, especially when requirements have been identified late or or projects have been delayed. The mitigation projects have been getting delayed. So we are wanting to, our first choice is to explore what I was calling a risk-based approach that would be proactive to help address the timing concerns. But I expect we'll hear a lot of comments on this, but this is not for us a parked issue. We'll be looking for the whole range of comments, but we wanted to let you know where our first thoughts were going on a possible path to addressing the primary concern about getting resources online and being able to participate in the RA program as quickly as possible. Next slide, please. So, this also stemmed this issue of overarching concern with delays of deliverability network upgrades, whether they were for an N-1 or N-2, whatever's been driving them. This has obviously also been a concern for us. And as we ramp up from adding a couple of thousand megawatts a year to the last few years, around averaging 4,000 megawatts of new installed capacity, this year we're looking at there's a good chance we break 8,000 megawatts of installed capacity, but then needing to sustain that level of development upsets the people's development schedules are a real concern to us. Obviously, the best case scenario is that we don't have the disruptions or the delays, but if we do, how do we manage around them? And we'd be interested in your thoughts on alternatives there, because having projects that are moving forward get disrupted, a scramble for alternative resources, it's a risk as well. So now we're talking about dueling risks. How do we manage that and sustain the pace of throughput that we need? So this is another area where we see more discussion. It's not directly tied to the deliverability methodology, but that's also where we see some pressure to soften the requirements, is because it seems to primarily be about timing, and we appreciate that concern. Next slide, please. We had received a number of comments about Diablo Canyon. I don't think we've really touched on that to this point, so I did want to just spend a minute there. We've been trying to clarify the amount of capacity that could be absorbed at Diablo Canyon prior to the nuclear plant retiring and then after. We have been coordinating that information, of course, with the state agencies and BOEM. We do see that the timing of Diablo Canyon retirement and other parties' access to capacity is a concern, especially with the leases that have now been issued. I want to reiterate that our current approach is that we do not rely on Diablo Canyon after 2025 in resource planning or in calling on Diablo Canyon to support the transmission system, but we do have to include it in our studies because while it's still there, we have to be reliably operating it. Also, there is an expectation that while Diablo Canyon is not included in resource planning, it is expected to be providing RA capacity up to its retirement. So those are complications we have to take into account. We also recognize PG&E hold generator interconnection agreement based rights for repurposing that extend for a period after the retirement. So this issue of how deliverability for that incremental capacity can be accessed is an issue, but to us, it's not a deliverability methodology issue, but it is an issue that will require more industry discussion. Next page, please. As we already talked about this one as well, separating local capacity resources from system capacity would require a very major shift in resource accounting and tracking through the state agencies as well as with the ISO. So this is something that to us is much bigger than a deliverability methodology question, because once you make this shift, what do you do with them? How do you manage that as a program going forward? So that's something that does need bigger discussion. And as I mentioned to Susan, I don't believe a timeline's been established, but we have talked to the RA team at the ISO and agreed that this issue needs to be addressed there from a more policy perspective before you dive too far into the details of how you would actually do the calculations and how you would operate the system if there's simultaneous need. So that's for that one we see going for discussion. Next slide, please. This issue of simultaneous dispatch of resources inside a generation pocket, it does seem that I feel like there are still differences of opinion about the purpose of both the RA framework as well as our deliverability process or methodology. At the same time, we appreciate the challenge of maintaining a large fleet in our interconnection queue through the interconnection process that have fully fleshed out and are, quote, available to provide deliverable service as LSCs are going through a subsequent procurement process. And that timing gap is a real concern. We don't see just softening the standards as the solution, but the coordination of resources going through detailed interconnection processes and then starting almost at a blank page with PPAs, we do see that we need more transformative changes in the entire interconnection process itself to better align the resource planning, transmission planning, interconnection, and resource procurement itself. So that broader basket of issues is something that is a concern that we need to talk about in the interconnection process enhancements efforts. That had what I think was a very successful kickoff call yesterday, teeing up some working group discussions that need to step back and think more holistically about how do we manage this issue with a higher volume of applications and a higher volume of projects that actually need to get through, procured, and connected. So we're looking forward to that discussion, but I think more of that is going to be occurring in the interconnection process enhancements efforts. Next slide, please. Dispatch levels. I think we've already talked about this as well, that the qualifying capacity levels that are determined based on a stochastic analysis over an entire year don't necessarily give us comfort around the purpose of the deliverability methodology about the ability of the resource to help meet system needs at times of system stress. I expect we'll get more input on that as we move forward in this, and we'll be looking forward to your comments. Let's see, I think that's, let me just see, next slide, please.
All right, thank you. I don't think I see any questions right now. Oh, yes, I think we're good. All right, well, thank you. Thank you. Thanks, Neil and Robert. Great conversation today. Again, here's our initiative schedule, and you can find this on the webpage. So you'll see that we've already posted the issue paper. We had our meeting today to discuss that issue paper. And then we're asking for comments June 22nd. And that comment template is live on the initiative webpage, so you can access that right away. And we'll plan to post the straw proposal July 26th and then have another meeting to discuss that August 2nd. And this is all with the goal to go to the Board of Governors in the winter of this year. And like I said, comment to do June 22nd. There's the link for the initiative webpage, so you can go access that comment template. And if you have any questions, feel free to reach out at isostakeholderaffairs@CAISO.com. We really appreciate everybody staying over time today and participating in such a great conversation. So we'll see you next time. Have a great rest of your day.
Concludes our conference. Thank you for using Event Services. You may now disconnect.